Already I am there. I have
Yes,
already
yes,
joined
sir.
at 10 o'clock.
Yes, sir. Just now we got the message, so we are adding you in as a presenter.
Madam, please start.
Yes, sir. Yeah. So now we are starting with the FDP. Good morning, everyone. A very warm welcome to all the respected faculty members, dignitaries, and participants to this online faculty development program for the subject Digital Electronics and Logical Design, organized under the academic framework of Savitribai Phule, Pune University. I am Professor Kumkum Bala, and I feel honored to be your honest for this session. This FDP aims to deepen our understanding of DELD, which is a subject that lies at the core of electronics and computer engineering, and to equip us with the pedagogical tools to enhance students' engagement and performance. So, before starting with the faculty development program, first of all, let's begin with the Light of Knowledge and Wisdom by Ganpati Vandana, sung by Dr. Sanket Pawar sir. Sanket Pawar sir.
Thank you, madam. Good morning, one and all present over here. So I'm going to sing Ganesh Vandana. गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गृह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यगलक्षेत्रे गुरुधर्म सदाराध्याय गुरुपुत्र परित्रात्रे गुरुपाखण्ड खण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि ग्रन्थगीताय ग्रन्थगेयाय ग्रन्थान्तरात्मने गीतलीनाय गीताशयाय गीतवाद्यपटवे गेयचरिताय गायक्रवराय गन्धर्वप्रियकृते गायकाधीनविग्रहाय गङ्गाजलप्रणयवते गौरीस्तनन्दनाय गौरीहृदयनन्दनाय गौरभानुसुताय गौरी गणेश्वराय गौरीप्रणयाय गौरीप्रवणाय गौरभावाय धीमहि गोसहस्राय गोवर्धनाय गोपगोपाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि. Thank you so much.
Thank you, Dr. Sanket Pawar sir, for this beautiful Vandana. Let's clap for Sanket Pawar sir. Let this FDP be a journey of collective learning and mutual growth. So this initiative has been made possible under the visionary guidance of our Dean of Faculty of Science and Technology, Dr. Pramod Patil sir, Dr. Nilesh Uke sir, SPPU Board of Studies, Chairman of Computer Engineering, Dr. Deepak Patil sir, BOS member SPPU, Dr. Neeta Deshpande madam, the SPPU FDP coordinator, and our principal Dr. R.N. Patil sir, and the Bharati Vidyapeeth's management team, who has always supported us for such kind of initiatives and worked tirelessly for academic excellence. So welcome all of you respected dignitaries to this FDP session. Let's welcome, I would like to invite Dr. Uday Patkar sir to introduce this FDP. Dr. Uday Patkar sir.
Thank you, madam. Thank you very much. Respected dignitaries, estimated resource person, dear faculty colleagues and participants, a very good morning to one and all. It gives me immense pleasure to welcome you all for this faculty development program organized by Department of Computer Engineering, Bharati Vidyapeeth's College of Engineering, Lavale, Pune. I, Dr. Uday Patkar, head of the department, and I feel extremely privileged to address this august gathering of academicians and experts. Let me take this opportunity to introduce our department briefly. The Department of Computer Engineering comprises 247 bright and enthusiastic and dynamic students, guided and mentored by 12 highly qualified faculty members. Among them, 3 faculty members have completed their PhD and 7 are currently pursuing their PhD from recognized universities. Our department hosts 9 well-equipped laboratories and 4 modern classrooms. Over the year, our faculty and students have made significant contribution to research and innovation, with 459 research papers published in reputed national as well as international journals and conferences. We are also proud to share that 44 patents have been filed, published, and out of them, 5 which have been granted till date now. Furthermore, 7 startups emerged from our department and showcasing our culture of entrepreneurship and innovation. Our students are working on prestigious real-world projects with organizations like DRDO, Indian Meteorology Department, NCL, Tata Hospital, which is available in Mumbai, Reliance Industry, SCL, and many more organizations. In addition to that, they actively reflecting their commitment to the continuous learning. In terms of academic excellence, our department has continuously achieved the remarkable results with 90% result in second year, 95% in third year, and proud to say that 100% result in final year. Our placement percentage stands at an impressive 91% for the academic year 24-25, having the highest package of 19 lakh rupees per annum. Our students have also made us proud by participating in national level competitions and winning, which includes prizes of worth rupees 1 lakh and 3 lakh in Smart India Hackathon and UNESCO Hackathon respectively. Now, it is with great pride and gratitude that I share that we have received a golden opportunity to conduct this faculty development program for second year computer engineering on the basis on the new syllabus designed under the National Education Policy Framework. This initiative has been made possible under the visionary guidance of our beloved Dean, Dean of Faculty and Science Technology, Dr. Pramod Patil sir, and SPPU Board of Studies Chairman for Computer Engineering, Dr. Nilesh Uke sir. I extend my heartfelt thanks to both of them for their leadership and support. I would also like to place on record my sincere appreciation to Dr. Deepak Patil sir, who is BS member of Savitribai Phule University, and Dr. Neeta Deshpande madam, the Savitribai Phule University Faculty Development Program Coordinator, and for their continuous coordination and encouragement. I am very much thankful to today's resource person, Dr. Chaya Jadhav madam, Dr. Lalita Vani madam, Dr. Vishnu Sriyaushi sir, Dr. Shanti Guru madam, Professor Ashish Javke sir, for giving their valuable time for this faculty development program. Till now, 178 faculty members from various colleges participated in this faculty development program. I welcome to all of them. My deep gratitude also goes to our dynamic and supportive principal, respected Dr. R.N. Patil sir, and the Bharati Vidyapit management for giving us the golden opportunity with this significant responsibility. This faculty development program aims to enrich the faculty members with a comprehensive understanding of the revised curriculum, the approach aligned with the national education policy and the emerging technology shaping the future of computer engineering education. I am confident that the computer engineering education, I am confident that this the session schedule will be interactive and most beautiful for the faculty, those who are present here. Once again, I welcome you all and wish this faculty development program great success. सर्व महत्वाचं म्हणजे या कार्यक्रमाला अर्जुन उपस्थित राहिलेले आमचे डॉक्टर प्रमोद पाटील सर, डीन सावित्रीबाई फुले युनिव्हर्सिटी, त्याचबरोबर आमचे मार्गदर्शक, दुसरे मार्गदर्शक डॉक्टर निलेश उके सर, बोर्ड ऑफ स्टडीचे प्रमुख चेअरमन, त्यांचं देखील मी मनापूर्वक स्वागत करतो आणि त्यांचे आभार मानतो की त्यांनी आम्हाला हा कार्यक्रम करण्याची संधी दिली. आणि त्याचबरोबर या कार्यक्रमाला आवर्जून उपस्थित असलेले आमचे माननीय प्राचार्य डॉक्टर आर.एन. पाटील सर, त्यांचं अनमोल असं मार्गदर्शन आम्हाला प्रत्येक वेळेला असतं, त्यांचे देखील मनपूर्वक आभार मानतो. आज दीपामावस्या आहे. प्रत्येकाच्या मनामध्ये नुसत्याच साधं गोष्टी होणार नाही, तर नॅशनल एज्युकेशन पॉलिसी जी आहे, राष्ट्रीय शैक्षणिक धोरणाची दीप हे प्रत्येकाच्या मनामध्ये उजळ, ही भगवंताची प्रार्थना करतो आणि माझ्या वाणीला विराम देतो. धन्यवाद. थँक्यू व्हेरी मच.
Thank you, sir, for briefing the Department of Computer Engineering and Bharati Vidyapit's College of Engineering, Lavale, Pune. Now, I would like to invite Dr. R.N. Patil, sir, principal, respected principal, sir, to share his wisdom words.
Thank you, madam. I hope I am audible.
Yes, sir.
Dean of Savitribai Phule University, Dr. Pramod Patil. Sir, let me apologize. When you joined, I was busy on a call with my head office, so I could not welcome you at that particular moment.
Sir, no issues. Yeah.
Same happened with Dr. Nilesh Uke, because with a difference of few minutes you joined here. But you are coming to, may not be physically in the college, but on the online platform. And I could not welcome you at that moment. So what was pending since then? So welcome Dr. Nilesh Uke and Dr. Pramod Patil for this FDP that is arranged by Bharati Vidyapit's College of Engineering, Lavale, Pune. Obviously under guidance of all the SPPU, Dean, Board of Studies, Chairman and the members of the Board of Studies. Then the speakers for around 5 sessions that we have arranged for 5 units. All these Dr. Vishnu Suryamshi, Dr. Lalita Vani, Dr. Chaya Jadhav, Mr. Ashish Javke and Dr. Shanti Guru. Dr. Neeta Deshpande, who is coordinating all these FDPs. They are all participants and faculty members who have joined from various institutes, and as well as the faculty members of this institute, head of the department, Dr. Uday Bhatkar, who has taken considerable amount of efforts for organizing this program. And though I was occupied with lot many things in the last week, he organized everything quite successfully. Rather today morning only I could see the detailed session plan, but was only aware that this is being organized today. So I welcome all of you at Bharati Vidyapit College of Engineering, Lavale. Dr. Uday Patkar, being a very talkative person, he has talked about the institute as well as the department, various achievements. So instead of repeating those things, it's better to proceed further with the business of the day, because that is more important. As such, now we are into second year of NEP implementation, but probably for Dean and BOS chairmen, it has started long ago, going through the various guidelines which are given by our regulating authorities, Government of India, Government of Maharashtra, and implementing those very successfully. Pramod Patil sir, I will like to mention a very important thing, that what I could observe is that during this phase of implementation, I know, to what extent you have taken the efforts. You had again been our guest here for educating us on the implementation of NEP 2020. And that, frankly speaking, really helped us a lot in actual implementation of NEP 2020, especially when the curriculums are being revised. Till earlier revision, we can say, things were pretty simple. But with implementation of NEP and including various aspects into the curriculum, that was really challenging. And as such, it's almost now more than 3 weeks we have started this implementation of NEP 2020 for the second year programs. This workshop is very significant because as a university, obviously, we need to maintain a level of teaching and learning of the students across all the affiliated institutes. For the autonomous institutes and other institutes, the matters are different, but these are rather huge tasks on the shoulders of the officials like you and US chairman, that the same has to be maintained throughout the across the university, across all the institutes, and having what we can say a different altogether perspective, because there are some institutes which are consistently ranked in NBA. There are few which are there in NIRF, and whereas there are few which are into rural areas where they are maybe facing scarcity of the faculty members. And sir, as you are aware that the call could not go through, but when I was trying to invite you and when we conducted the interviews at our head office, the problem, especially with the computer related branches, is really very challenging, because getting sufficient number of good faculty members, we may get a lot number of faculty members, but getting good number of faculty members, even for a reputed organization like Bharati Vidyapit, is challenge. And out of all such challenges, taking all the colleges together is rather a very big challenge for to you as a dean, and to Dr. Nilesh Uke as the chairman board of studies. But what we can say, this Shivadhanush has been very successfully held, and we are quite assured that it is in the competent and intelligent hands. And as we will progress further through third year and fourth year of the implementation of even NEP, we could see all the success, and university will bring as such. Pune University is a role model for many of the universities of Maharashtra, and that our name and fame will remain there. So instead of going in much details about the institute or institute's achievements and all that, as it has already been given by Dr. Uday Patkar, I wish all the success for this program, and definitely it will be successful when you stalwarts like you are with us. So thanks to all the members. First of all, the members of audience, members in the audience, I can say the faculty members who have joined for this. because without their participation, this would not have been any more fruitful. And for those guiding personalities here, Dr. Pramod Patil, Dr. Nilesh Uke, then uh, Dr. Vishu Suryavanshi, Lalita Vani, Chaya Zadav, Ashish Zavke, and Shanti Guru. Thank you all of, thanks to all of you, and especially to Dr. Nita Deshpande, who is coordinating all these FDPs across the universities and making them successful. Thank you for being with us uh, for this online FDP. Actually, I was insisting to Dr. Patkar that let it be offline, let the members come here. It would be a kind of gathering and more exchange of ideas and all those. But in the current scenario, academics has already started. There are few colleges right at the almost at the corner of North Maharashtra, somewhere in the Nasik district, and so for many of them, it would have been really challenging to travel that much distance and spare 1 or 2 days for attending it. So at least by making it online, you could get good number of participants, and the main purpose, maintaining the parity of teaching and learning across all the institutes, will be maintained. So thanks to all of you for being with us. All the members present here are cordially invited to this institute whenever they get good time. So thanks to all of you. Thank you very much. Bala Madam, over to you.
Thank you, sir. Thank you for your guidance, well wishes, and inspiring us always to take such kind of initiative. Thank you, sir. Now I would like to invite our respected Dr. Nilesh Uke, sir, Chairman, BOS Computer, SPPU.
Good morning, all of you.
Okay, sir, please unmute.
I am unmute.
Sir, Ritu ma'am will introduce, then we'll start.
Yeah, good morning, all of you. Thank you for inviting me for this faculty orientation program. Dr. Patil, Dr. Uday Patkar, my friend and colleague, University Authority, Dr. Pramod Patil, for helping us out in designing this curriculum. For last 6 to 7 months, we are working on that. And I think computer department is very huge, and they have given us, all of you have given us very good inputs. And finally, we got the nicest of the curriculum with us. This FOP, as far as computer board is concerned, I think this is 9th and 10th for faculty orientation program going on. And every faculty is getting involved in this. And I'm very happy. Most of my faculty members are enthusiastic in organizing and also as well as in attending it. I wish very best luck for all the participants, all the speakers today. Dr. Vishnu, Dr. Latika, Dr. Shaya, Ashish Varke, and Dr. Shanti Guru, along with Dr. Patkar, who are going to talk and discuss the contents. It's not that what is to be taught there. We are going to discuss the contents, how the things should go to our students. Secondly, at the end of this workshop, I expect that you learn NAP, because NAP is far away from us. We are just in second year, but everybody has executed NAP in first year very nicely. We do not have any issue, students issue or faculty issue. At the end of this faculty orientation program, I expect a good amount of deliberations by each faculty member, lab manuals to be created so that they can be circulated in every institute. Course materials you can discuss and circulate among yourself. Some videos, if you have created, let them get circulated to each one of you. I need a panel of examiners from your side. So those who are teaching this subject, Dr. Patkar, kindly submit me the list. And if you have good number of case studies to be done, kindly submit those. And if you have even a smallest thing to be changed, we can change it if at all it is required to be added into the curriculum. We are still learning, and we expect that smallest, what I can say, alteration, modification, if it is changing our students' perspective, we should do it. Thank you very much for inviting me. and we wish you best luck for today's faculty orientation program.
Thank you, sir. Thank you, respected Nilesh sir, for your unwavering support and guidance and for your well wishes. Thank you. Now I would like to invite respected Dr. Pramod Patil, sir, Dean Savitribai Phule, Pune University. Sir, over to you.
धन्यवाद मॅम.
Thank you, sir.
सर्वप्रथम सुप्रभात. आणि आज दीप अमावस्या असल्यामुळे दीप अमावस्येच्या सर्वांना खूप खूप शुभेच्छा. माझा आवाज येतोय सर्वांना?
Yes.
ओके.
Yes, sir.
या व्हर्च्युअल प्लॅटफॉर्मवर उपस्थित अध्यक्ष, अभ्यास मंडळ, संगणक अभियांत्रिकी डॉक्टर निलेश उके सर, सर्व सन्माननीय सदस्य, अभ्यास मंडळ, संगणक अभियांत्रिकी, प्राचार्य आदरणीय डॉक्टर आर.एन. पाटील सर, विभाग प्रमुख डॉक्टर पाटकर सर, कोऑर्डिनेटर फॅकल्टी डेव्हलपमेंट प्रोग्राम डॉक्टर नीता देशपांडे मॅडम, आणि या फॅकल्टी डेव्हलपमेंट प्रोग्रामसाठी लाभलेले सर्व रिसोर्स पर्सन डॉक्टर विष्णू सूर्यवंशी, डॉक्टर ललिता वाणी मॅम, डॉक्टर छाया जाधव मॅडम, डॉक्टर आशिष, डॉक्टर शांती गुरु, सर्वप्रथम मी सर्वांचे खूप खूप मनापासून धन्यवाद देतो की तुम्ही वेळात वेळ काढून या प्रोग्रामसाठी जॉईन झालात. आणि जसं उके सरांनी आपल्याला सर्वांना सांगितलं की प्रत्येक विषयाचा फॅकल्टी डेव्हलपमेंट प्रोग्राम हा आपण सर्वांसाठी कंडक्ट करतोय, प्रत्येक विषयासाठी कंडक्ट करतोय. आणि त्यासाठी लागणारे जे काही एफर्ट्स आहेत, कष्ट घेतले जात आहेत, ते फक्त अभ्यास मंडळापुरतेच मर्यादित नव्हे, तर ते प्रत्येक महाविद्यालयातून प्रत्येक शिक्षकाकडून आपल्यापर्यंत ते पोहोचतायत. आणि आपण एक चांगल्या पद्धतीचं शिक्षकांना या व्हर्च्युअल प्लॅटफॉर्मवर आणून प्रत्येक विषयासाठी लागणारी जी काही यंत्रणा आहे, कंटेंट डिलिव्हरीसाठी असेल किंवा एक्झामिनेशन असेसमेंटसाठी असेल किंवा वेगवेगळ्या पद्धतीच्या ज्या काही गोष्टी असतील, याचे मार्गदर्शक तत्व इथं आपण एकत्रितपणे चर्चेत यावेत अशी मी अपेक्षा करतो. आणि आपल्याला सर्वांना ज्ञातच आहे की आपण एक चांगल्या पद्धतीचं NAPचं इम्प्लिमेंटेशन, हे शैक्षणिक धोरण 2020, आपण एक चांगल्या पद्धतीचं इम्प्लिमेंटेशन, त्याची अंमलबजावणी विद्यापीठ स्तरावर सर्व संलग्नित महाविद्यालयांमध्ये आपण आता सुरू केलंय. शैक्षणिक वर्ष 2024-25 ला आपण पहिल्या वर्षामध्ये शैक्षणिक धोरण याची अंमलबजावणी केली. अतिशय चांगल्या पद्धतीने त्याची अंमलबजावणी झाली. आणि प्रत्येक शिक्षकांनी, प्रत्येक महाविद्यालयाच्या प्राचार्यांनी, प्रत्येक विभागातील विभाग प्रमुखांनी याच्यामध्ये त्यांचा सहभाग नोंदवला, चांगल्या पद्धतीने सहभाग नोंदवला. आणि जिथं जिथं आपल्याला काही अडीअडचणी आल्यात, त्या अडीअडचणींवर सुद्धा आपण मात केली. तर याला एक सर्व टीमवर्क खूप चांगल्या पद्धतीने याचं इम्प्लिमेंटेशनसाठी आपल्याला मिळालं. आणि त्यासाठी मी खरं म्हणजे सर्व महाविद्यालयाचे प्राचार्य, विभाग प्रमुख, शिक्षक, शिक्षकेतर कर्मचारी आणि त्या संस्थेचे जे काही मॅनेजमेंट असेल, त्या मॅनेजमेंटचे सर्वांचे आपण सर्व मिळून धन्यवाद व्यक्त करू. विद्यापीठाच्या स्तरावर ऑनरेबल व्हाईस चान्सलर सर असतील, प्रो व्हाईस चान्सलर सर असतील किंवा इतर विद्याशाखांचे अधिष्ठाता असतील, या सर्वांचे आपल्याला हे राष्ट्रीय शैक्षणिक धोरण 2020 आपल्या इंजिनिअरिंग एज्युकेशन मध्ये, अभियांत्रिकी एज्युकेशन मध्ये आपल्याला एक चांगल्या पद्धतीने इम्प्लिमेंटेशन आपण सुरू केलं आहे. मित्रांनो, आपल्याला ही गोष्ट ज्ञातच आहे की भारताला ज्ञान महासत्ता बनवण्यासाठी हा सगळा नवीन राष्ट्रीय शैक्षणिक धोरण याचा आराखडा तयार करण्यात आला आहे आणि त्या पद्धतीचं एक चांगलं दर्जेदार शिक्षण आपल्या विद्यार्थ्यांना आपण कसं देऊ शकतो यासाठी हा एक चांगला प्रयत्न आपल्या भारत सरकारने आणि महाराष्ट्र सरकारने घेतलेला आहे. हे करत असताना विद्यार्थ्यांमध्ये आवश्यक कौशल्य व ज्ञान प्राप्ती आणि विज्ञान, तंत्रज्ञान, शिक्षक आणि औद्योगिक क्षेत्रामधील मनुष्यबळाची कमतरता दूर करण्यासाठी हे नवीन राष्ट्रीय शैक्षणिक धोरण 2020 मला असं वाटतं आपण आपल्या देशामध्ये हे राबवतो आहोत. यासाठी जे काही आपण कष्ट घेत आहोत त्या कष्टांचा उपयोग आपल्या भारतातील लोकसंख्येला त्यांची गुणवत्तापूर्ण शिक्षण कसं आपण त्यांना देऊ शकतो त्याच्यासाठी आपला हा प्रयत्न आहे. त्यांना आपण नाविन्यपूर्ण शिक्षण कसं देऊ शकतो त्याच्यासाठी आपला हा प्रयत्न आहे. आणि हेच सगळं करत असताना फक्त शिक्षण देण्यापुरतच आपण मर्यादित ठेवत नाहीये, तर आपण संशोधनाच्या ज्या काही वेगवेगळ्या सुविधा उपलब्ध करून देण्यासाठी ज्या काही गोष्टी लागतील त्या गोष्टींचा विचार करून त्याचं सुद्धा आपण इम्प्लिमेंटेशन आता या नवीन शैक्षणिक धोरण 2020 मध्ये घेऊन आलोय. तर मला असं वाटतं हे नवीन शैक्षणिक धोरण एक आपल्या शिक्षण पद्धतीमध्ये एक आमूलाग्र बदल करण्याचं एक मोठं उद्दिष्ट त्याच्यामध्ये दिसतंय आणि ते बदल घडत असताना वेगवेगळ्या अडीअडचणी आपल्याला येऊ शकतात. जसं की आता सेकंड इयर मध्ये आपण बघतोय की सेकंड इयर मध्ये प्रत्येक अभ्यास मंडळांनी एक चांगल्या पद्धतीचं सिलेबस, एक चांगल्या पद्धतीचं अभ्यासाचं स्ट्रक्चर आपल्या मुलांपर्यंत आपण घेऊन गेलेलो आहोत. फर्स्ट इयर मध्ये आपण सक्सेसफुली रन केलं. आता सेकंड इयर मध्ये सुद्धा एक चांगल्या प्लॅनिंगनी आपण पुढे चाललो आहोत. प्रत्येक गोष्ट ही वेल डिफाईन आहे आणि त्यासाठी मला खरंच म्हणजे सर्व अभ्यास मंडळाचे अध्यक्ष आणि त्या अभ्यास मंडळातील सदस्य यांचं तोंड भरून कौतुक करावं असं वाटतं की त्यांनी सुद्धा जे काही कष्ट घेतलेत सिलेबस फ्रेम करण्यासाठी, कंटेंट फ्रेम करण्यासाठी, ते अतिशय खूप चांगल्या पद्धतीचे कष्ट आहेत आणि हे आपल्या मुलांना एक चांगली दिशा दाखवण्यासाठीचे कष्ट तिथं घेतलेले आहेत. चांगले सिलेबस देण्याचा प्रयत्न तिथं आहे. नवीन शैक्षणिक धोरणामध्ये सर्वांगीण आणि बहुविद्याशाखीय शिक्षण प्रणालीचा अंतर्भाव करण्यात आलेला आहे. हे आपल्याला सर्वांना माहितच आहे की वी आर गोइंग टू गिव्ह होलिस्टिक अँड मल्टीडिसिप्लिनरी करिक्युलम फ्रेमवर्क टू अवर स्टुडंट्स. आणि आता सेकंड इयर मध्ये जर तुम्ही बघितलं तर आपण जे काही कोर डिसिप्लिन जे काय आहे प्रोग्राम कोर कोर्सेस ते त्या डिसिप्लिनचे त्या विभागातील त्या बोर्ड ऑफ स्टडीज मधील जे काही विषय असतील ते विषय तर देतच आहोत, पण त्याच्यासोबत बहुविद्याशाखीय शिक्षण घेण्यासाठी जे काही कोर्सेस लागतात त्या कोर्सेसचा सुद्धा आपण अंतर्भाव या करिक्युलम फ्रेमवर्क मध्ये केलेला आहे. तर मला असं वाटतं हे शिक्षण प्रणाली एक इंटरडिसिप्लिनरी अप्रोच, मल्टीडिसिप्लिनरी अप्रोच और ट्रान्सडिसिप्लिनरी अप्रोच आपल्या विद्यार्थ्यांचा कसा वाढवता येईल याच्यासाठी हे धोरण आपल्याला खूप उपयुक्त ठरणार आहे. विद्यार्थी हे आपले केंद्रबिंदू असून त्यासाठी जे काय आपण व्हर्टिकल्स आता सेकंड इयर मध्ये घेऊन आलो, जसं की मी पीसीसी बद्दल बोललो, तसंच एमडीएम दॅट इज मल्टीडिसिप्लिनरी मायनर. आणि मला असं वाटतं आजचा जो काही विषय आहे डिजिटल इलेक्ट्रॉनिक्स आणि लॉजिक डिझाईन हा विषय हा खरं म्हणजे इलेक्ट्रॉनिक्स इंजिनिअरिंग असेल किंवा इलेक्ट्रॉनिक्स अँड टेलिकम्युनिकेशन असेल ह्या बोर्डातून तो विषय असतो, ह्या पर्टिक्युलर शाखेतून तो विषय असतो. तर आज जर कम्प्युटर इंजिनिअरिंगच्या विद्यार्थ्यांना आपल्याला मल्टीडिसिप्लिनरीचं जर काही कोर्सेस देता आलेत तर एमडीएम नावाचा 14 क्रेडिटचा कोर्स आपण सेकंड इयर टू फायनल इयर अशा पद्धतीने त्याचं डिझाईन करणार आहोत. आणि आता सेकंड इयर मध्ये आपण 4 क्रेडिटचे एमडीएम घेऊन आलेलो आहोत आणि त्यातला एक विषय म्हणून डिजिटल इलेक्ट्रॉनिक्स आपण इंट्रोड्यूस केलाय. आपण एमडीएम पुरतच मर्यादित हे क्रेडिट फ्रेमवर्क ठेवलेलं नाहीये, तर आपण बहुविद्याशाखीय शिक्षण देण्यासाठी जे काही ओपन इलेक्टिव्ह असतील, जनरिक इलेक्टिव्ह असतील, त्याचाही अंतर्भाव ह्या क्रेडिट फ्रेमवर्क मध्ये आपण केलेला आहे. आणि मला असं वाटतं की त्याचा उपयोग आपल्या मुलांना जसं की मॅनेजरियल स्किल्स किंवा फिनान्शियल स्किल्स किंवा कॉमर्सचे काही लागणारे स्किल्स असतील किंवा डिजिटल मार्केटिंगचे स्किल्स असतील किंवा इतर कुठलेही विद्याशाखेतील स्किल्स असतील, जसे की आर्ट्स अँड ह्युमॅनिटीज असेल, कॉमर्स अँड मॅनेजमेंट असेल, इंटरडिसिप्लिनरी स्टडीज असेल, ह्या विद्याशाखेतून जे काही चांगले कोर्सेस इंजिनिअरिंगच्या मुलांना पुढे चालून लाईफ लॉंग लर्निंगसाठी त्याचा फायदा होईल किंवा पुढे चालून हायर स्टडीजला किंवा त्याला एखाद्या इंडस्ट्रीमध्ये ज्यावेळेस जाऊन तो काम करेल तेव्हा त्याला तिथं कुठेतरी फायदा होईल, तर त्या गोष्टीचा सुद्धा विचार आपण केलेला आहे आणि त्या पद्धतीचे कोर्सेस आपण या करिक्युलम फ्रेमवर्क मध्ये घेऊन आलोय. आपण फक्त ज्ञान त्या डिसिप्लिनचं किंवा वेगवेगळ्या डिसिप्लिनचं किंवा वेगवेगळ्या फॅकल्टीचं तेवढ्याच पुरतं मर्यादित ठेवलेलं नाही, तर आता नवीन शैक्षणिक धोरण याच्यामध्ये कौशल्य विकास, विद्यार्थ्यांमध्ये आवश्यक कौशल्य विकास आपण कसा करता येऊ शकतो याचाही विचार केलेला आहे. आणि त्या पद्धतीचे स्किल एनहान्समेंट कोर्सेस असतील किंवा व्होकेशनल स्किल एनहान्समेंट कोर्सेस असतील ते सुद्धा आपण इंट्रोड्यूस केलेले आहे. मुलांचा तो चॉईस असेल, मुलांचा तो आपला स्वतःचा एक विचार असेल की मला ह्या पर्टिक्युलर व्हर्टिकलमध्ये ह्या पर्टिक्युलर स्किलसाठी जायचंय, तर त्या स्किल्स रिलेटेड कोर्सेस ते मुलं चूज करू शकतील. तर आपण अशी स्किल एनहान्समेंट कोर्सेसची सुद्धा बास्केट मुलांना अवेलेबल करून दिलेली आहे आणि ती फ्लेक्सिबिलिटी मुलांना दिलेली आहे. तर ती फ्लेक्सिबिलिटी या नवीन राष्ट्रीय शैक्षणिक धोरणामध्ये आपल्याला त्या गोष्टीचा अंतर्भाव झालेला दिसतोय. जसं मी बहुविद्याशाखीय शिक्षण प्रणालीचा अंतर्भावाबद्दल बोललो, असेच फक्त नसून त्याचा जो काही उद्देश आहे तो उद्देश आपल्याला समजून घेणं तेवढंच महत्वाचं आहे. आणि त्याचा उद्देश मला वाटतं मानवाच्या सर्व क्षमता नैतिक किंवा एकात्मिक पद्धतीने विकास करणे हाच मला दिसून आलेला आहे. आणि त्या गोष्टीच्या दृष्टिकोनातून सुद्धा फर्स्ट इयर मध्ये जसं आपण इंडियन नॉलेज सिस्टीम सारखे व्हर्टिकल्स असतील किंवा को करिक्युलर कोर्सेस असतील किंवा ॲबिलिटी एनहान्समेंट कोर्सेस असतील किंवा आता दुसऱ्या वर्षामध्ये आपण व्हॅल्यू एज्युकेशन कोर्सेस असतील, ह्या सर्व व्हर्टिकलचा पूर्णपणे मुलांना कसा त्याचा सर्व क्षमतांचा नैतिक किंवा एकात्मिक पद्धतीने विकास होईल यासाठी आपण प्रयत्न करतोय. आणि मग फर्स्ट इयर मध्ये आपण ॲबिलिटी एनहान्समेंट कोर्सेस मध्ये प्रोफेशनल कम्युनिकेशन स्किल मुलांचं कसं डेव्हलप करता येईल त्याच्याबद्दल विचार केला. आज आपण सेकंड इयर मध्ये मॉडर्न इंडियन लँग्वेज, आणि म्हणून मी मुद्दामून आज मराठीमध्ये बोलतोय कारण मॉडर्न इंडियन लँग्वेज मध्ये आपण मराठी मुलांना शिकवणार आहोत, व्यावहारिक मराठीचं ज्ञान मुलांना देणार आहोत. आणि म्हणून मला आवर्जून आज वाटलं की आपण आपलं जे काही प्रस्तावना असेल किंवा भाषण असेल की आपण हे मराठीतून सगळ्यांनाच द्यावं. तर सेकंड इयरच्या कम्प्युटरच्या मुलांना डिजिटल इलेक्ट्रॉनिक्स सुद्धा आपल्याला शिकवायचं आहे आणि त्यासोबत आपल्याला मराठी सारखा विषय सुद्धा त्या मुलांना शिकवायचे आहे. आणि नवीन शैक्षणिक धोरणामध्ये एज्युकेशन इन रिजनल लँग्वेज हे याचं मूळ प्रिन्सिपल आहे. तर ते प्रिन्सिपल आपल्याला कुठेतरी एक चांगल्या पद्धतीने इम्प्लिमेंटेशन करायचं आहे, जेणेकरून प्रत्येक विद्यार्थी, मग तो शहरी भागातला असू दे किंवा ग्रामीण भागातला असू दे, त्याला त्याच्या ज्या लँग्वेज मध्ये त्याला व्यवस्थितरित्या जो काही आपण टॉपिक किंवा कंटेंट डिलिव्हरी करणार आहोत ते कंटेंट त्याला व्यवस्थितरित्या कन्सेप्च्युअली समजलेत की नाही ते बघणं फार गरजेचं आहे. तर इथं एनएपी मध्ये प्रत्येकाच्या पोटेन्शियलला महत्व दिलेलं आहे, प्रत्येकाच्या अंडरस्टँडिंगला महत्व दिलेलं आहे, प्रत्येकाच्या प्रॉब्लेम सॉल्व्हिंग स्किलला महत्व दिलेलं आहे, प्रत्येकाचे क्रिटिकल थिंकिंग असेल किंवा क्रिएटिव्हिटी असेल त्याला महत्व दिलेलं आहे आणि एक मल्टी डिसिप्लिनरी एज्युकेशनला महत्व दिलेलं आहे. ह्या सर्व गोष्टींचा अंतर्भाव आपण आपल्या करिक्युलम फ्रेमवर्क मध्ये घेऊन येतोय. आणि म्हणून मला खरंच आवर्जून सांगावंसं वाटतं की प्रत्येक बोर्ड आणि प्रत्येक महाविद्यालय याच्यामध्ये खूप ऍक्टिव्हली पार्टिसिपेशन त्यांचं आहे. आणि हॅट्स ऑफ टू ऑल द टीचर्स, बिकॉज अल्टिमेटली टीचर्स आर गोइंग टू इम्प्लिमेंट दिस न्यू नॅशनल एज्युकेशन पॉलिसी व्हेरी इफेक्टिव्हली. आणि हे सगळं करत असताना त्यांना ज्या काही अडचणी येतील किंवा कुठं कोणाचा लोड कमी जास्त होत असेल किंवा काही समजत नसेल तर त्या गोष्टीसाठी आपण सगळ्या महत्वाच्या गोष्टी त्याच्यामध्ये आणतो आहोत. मित्रांनो, आपल्याला अजून एक दुसरी एक चांगली बाजू सांगायची आहे की इंडस्ट्री इंटिग्रेशन आणि रिसर्च इंटिग्रेशन म्हणजे औद्योगिक क्षेत्रामधील जे मनुष्यबळाची कमतरता कुठेतरी आज भासते, स्किल बेस्ड असेल किंवा डिसिप्लिन स्पेसिफिक असेल, तर त्या रिलेटेड सुद्धा आपण एफर्ट्स इथे घेतोय आणि त्या पद्धतीचं इंडस्ट्री कनेक्ट कसा आपल्याला वाढवता येतील किंवा त्या रिलेटेड कोर्सेस कसे इंट्रोड्यूस करता येतील आपल्याला थर्ड इयर आणि फायनल इयर मध्ये त्या गोष्टीचाही विचार करायचा आहे. आज आपण दुसऱ्या वर्षामध्ये ऑन जॉब ट्रेनिंग किंवा कम्युनिटी एंगेजमेंट प्रोजेक्ट नावाचं जे काही कन्सेप्ट घेऊन आलो आहोत त्याचा सुद्धा आपल्याला खूप चांगल्या पद्धतीने उपयोग करून घेता येतील. कम्युनिटी एंगेजमेंट प्रोजेक्ट म्हणजे सोसायटीमध्ये जाऊन सोसायटी मधले जे जे काही प्रॉब्लेम्स असतील ते प्रॉब्लेम समजून त्याच्यावर काय आपल्याला सोल्युशन देता येईल का, पॉसिबल सोल्युशन देता येतील का, तशा पद्धतीचं डिस्कशन तशा पद्धतीचे प्रोजेक्ट आयडियाज आपल्या मुलांना आयडेंटिफाय करायचे आहेत, त्याच्यावर सोल्युशन प्रोव्हाइड करायचे आहेत आणि त्याचं इम्प्लिमेंटेशन करायचं आहे. तर एक चांगल्या पद्धतीचं करिक्युलम फ्रेमवर्क इथं आपण आपल्या मुलांपर्यंत घेऊन जातोय, ज्याला नेहमीच आता आपले बरेच जे काही वरिष्ठ मंडळी आहेत ते आपल्याला सांगत असतात की लोकल टू ग्लोबल आपल्याला जायचंय. लोकल लेवलचे प्रॉब्लेम्स निराळे असतात, ग्लोबल लेवलचे प्रॉब्लेम्स निराळे असतात, तर प्रत्येक प्रॉब्लेमला आपल्याला ऍड्रेस करायचंय थ्रू दिस करिक्युलम फ्रेमवर्क. म्हणजे मुलगा जरी लोकल लेवलला राहिला तर त्याला लोकल लेवलचे प्रॉब्लेम्स आणि तिथं त्याचा औद्योगिक विकास कसा करता येईल त्या दृष्टिकोनातून आपल्याला काही कोर्सेस इनलाईन विथ एनएपी 2020 आपल्याला इथे इंट्रोड्यूस करायचे आहेत. आणि मला असं वाटतं त्या पद्धतीचं पाऊल आपण ओजीटीच्या माध्यमातून किंवा कम्युनिटी एंगेजमेंट प्रोजेक्टच्या माध्यमातून किंवा प्रॉब्लेम अँड प्रोग्रामिंग लँग्वेजेस या माध्यमातून किंवा आयडिया थिंकिंग अँड डिझाईन थिंकिंग अँड आयडिया लॅब ह्या सारख्या कोर्सेसच्या माध्यमातून आपण मुलांमध्ये त्या गोष्टी न्यायला सुरुवात केलेली आहे. आणि हे सर्व चांगल्या पद्धतीने इम्प्लिमेंटेशन कधी होईल, जेव्हा सर्व शिक्षक एक चांगल्या पद्धतीच्या गाईडलाईन्स, एक हा प्लॅटफॉर्म कशासाठी फॅकल्टी डेव्हलपमेंट फॅकल्टी ओरिएंटेशन प्रोग्रामचा हा प्लॅटफॉर्म आपल्याला त्यासाठीच वापरायचा आहे की आपण ह्या विषयामध्ये द बेस्ट काय आहे किंवा द ग्रेट ऑपॉर्च्युनिटीज काय काय आपल्या मुलांना आहेत त्या गोष्टींचा विचार करणं आपल्याला गरजेचं आहे. तसेच जे कंटेंट्स आपण डिलिव्हर करणार आहोत ते किती इफेक्टिव्हली मुलांपर्यंत जायला पाहिजे याचा विचार आपल्याला या प्लॅटफॉर्मवर करणं अपेक्षित आहे. किंवा ज्या असेसमेंट आपण करणार आहोत म्हणजे थेरीचे असेसमेंट आपलं ऑलरेडी ठरलेलं आहे पॅरामीटर 30-70 म्हणजे कॉम्प्रिहेन्सिव्ह कंटिन्युअस इव्हॅल्युएशन आणि एंड सेमेस्टर एक्झामिनेशन. तसंच प्रॅक्टिकलचे जे काही प्रॉब्लेम स्टेटमेंट असतील तर ते त्याचं इव्हॅल्युएशन असेल, त्याचं कंटिन्युअस असेसमेंट असेल तर ते कंटिन्युअस असेसमेंट शुड बी बेस्ड ऑन कॉम्पिटन्सी parameters. So competency based assessment parameter needs to be discussed on this virtual platform. तर त्याचा सुद्धा आपल्याला इथं मला असं वाटतं की हा प्लॅटफॉर्म वापरता येईल आणि त्या गोष्टीचं जर तुम्ही चांगल्या पद्धतीचे गाईडलाईन्स घेऊन कॉमन गाईडलाईन्स, युनिफॉर्म गाईडलाईन्स जर सगळ्यांना दिल्यात तर मला असं वाटतं की आपण कम्प्युटर बोर्डमध्ये किंवा आपल्या फॅकल्टी ऑफ सायन्स अँड टेक्नॉलॉजीमध्ये एक चांगलं एनईपीचं इम्प्लिमेंटेशन म्हणून एक आदर्श म्हणून आपण पुढे येऊ आणि बाकीचे विद्यापीठ नेहमीच पुणे विद्यापीठाला फॉलो करत असतात तर तो पायंडा आपण पुढे कायम ठेवू आणि ह्या नवीन शैक्षणिक धोरणासाठी आपण एक चांगल्या पद्धतीचं अजून काय चांगलं करता येईल त्या गोष्टीचा विचार करू. इंडस्ट्री कनेक्ट जसं म्हटलं मी तसंच वी नीड टू प्रमोट रिसर्च ड्रिव्हन लर्निंग. आता जरी आपण सेकंड इयरच्या मुलांना डिजिटल इलेक्ट्रॉनिक्स शिकत असलो तरी सुद्धा आपल्याला कुठेतरी एक बघायला पाहिजे की याच्यामध्ये संशोधनासाठी काही ऑपॉर्च्युनिटीज आहेत का आपल्या मुलांना. कारण आपण एक डिग्री जी आहे ती आपली ऑनर्स विथ रिसर्च असणार आहे म्हणजे संशोधनाच्या रिलेटेड आपण डिग्री मुलांना ऑफर करणार आहोत. सो दिस इज द राईट टाइम टू स्टार्ट विथ टू मोटिवेट अवर स्टुडंट्स, एनकरेज अवर स्टुडंट्स फॉर रिसर्च अँड डेव्हलपमेंट, इनोव्हेशन, इन्व्हेन्शन अँड स्टार्टअप्स. तर त्या दृष्टिकोनातून सुद्धा आपल्याला ह्या विषयाकडे बघायचं आहे आणि त्या पद्धतीच्या काही रिसर्च डिरेक्शन्स किंवा रिसर्च ड्रिव्हन लर्निंग कसं मुलांचं होईल याकडे आपल्याला लक्ष वेधायचं आहे. खूप चांगल्या चांगल्या गोष्टी आहेत, नक्कीच आपण टाइम टू टाइम डिस्कस करूच. आता मी जास्त वेळ घेत नाही कारण बरेच रिसोर्स पर्सन जे काही वेल नोन रिसोर्स पर्सन आहेत ते सर्व आतुरतेने वाट बघतायत, त्यांना त्यांची कंटेंट डिस्कस करायचे आहेत. तर मला इथं तुम्हाला एवढंच सांगायचं आहे की आपल्याला आपले जे काही ग्रॅज्युएट्स असतील तोच ग्रॅज्युएट शुड बी ग्लोबली कॉम्पिटंट आणि त्यांच्याकडे नॉलेज असेल, त्यांच्याकडे रिसर्च ऍप्टिट्यूड असेल आणि त्यांच्याकडे इनोव्हेशन करण्याची पॉवर असेल आणि एक चांगले एक मनुष्य म्हणून किंवा माणूस म्हणून ते पुढे येतील एवढीच आपण अपेक्षा करू. आणि हे बोलून मी माझे 2 शब्द इथं संपवतो. पुनश्च एकदा प्राचार्य महाविद्यालयाचे डॉक्टर आर.एन. पाटील सर, विभाग प्रमुख डॉक्टर पाटकर सर, चेअरमॅन बोर्ड ऑफ स्टडीज computer engineering Dr. Uke sir, all the members board of studies, all the resource persons, all the heads of the department of various colleges, all the principals of various colleges. I am very thankful to everyone for your active participation, contribution, cooperation and support to implement this new National Education Policy 2020 at Savitribai Phule Pune University. Thank you very much.
Thank you, sir. Thank you for your word of wisdom, for the detailed guidance about the syllabus, about the NEP framework and the CC mechanism. So thank you, sir. Now I would like to present vote of thanks for this session, and then we will start with all the sessions. So for vote of thanks, first of all, I would like to thank our guest of honor, Dr. Pramod Patil sir, Dean of the Faculty of Science and Technology, Savitribai Phule Pune University, Dr. Nilesh Uke sir, SPPU Board of Studies, Computer Science, Dr. Nilesh Uke sir, Chairman. Then I would like to thank all the session experts, Dr. Visu Suryavanshi sir, who will be taking Unit 1, Dr. Lalita Vani Madam, who will be taking Unit 2, then Dr. Chaya Jadhav Madam, who will be talking on Unit 3, Dr. Mr. Ashish Jauke sir, and Dr. Santi Guru Madam, who will be talking on Unit 5. So thank you all of you for joining this session. Now I would like to thank our principal, Dr. R.N. Patil sir, for his unwavering support and guidance. Also, I would like to thank Bharati Vidyapith's management team for constantly inspiring us for taking such kind of session and getting the knowledge. And last but not the least, I would like to thank all the participants who has taken their time and joining us for on this platform. To get the knowledge, to share their views for DELD subject. So thank you all of you for joining us. And I would like to request here all of you kindly turn on your camera so that we will be taking a screenshot. Then we will be starting with the session. Thank you, sir. Thank you all of you.
सगळ्यांना नम्र त्यांनी आपले कॅमेरे ऑन करावे. आदरणीय डॉक्टर प्रमोद पाटील सर, त्याचबरोबर डॉक्टर निलेश उके सर, आपण आपला बहुमूल्य वेळ दिला त्याबद्दल आपले कोटी कोटी धन्यवाद. आमच्या महाविद्यालयाचे प्राचार्य डॉक्टर आर.एन. पाटील सर यांना तातडीची एक आमच्या भारतीय विद्यापीठ भवन मध्ये मीटिंग आल्यामुळे ते आता ऑनलाईन होते, अजूनही आहेत, म्हणजे ते प्रवास करत असताना सुद्धा जॉईन करून ते ऐकतायत. त्याबद्दल त्या माननीय प्राचार्य डॉक्टर आर.एन. पाटील सरांचे सुद्धा धन्यवाद. आणि आपण सर्वजण आलात त्याबद्दल आपल्या सगळ्यांचे धन्यवाद. नक्कीच डॉक्टर प्रमोद पाटील सरांनी अनमोल असं मार्गदर्शन केलेलं आहे आणि मला असं वाटतं की नॅशनल एज्युकेशन पॉलिसी, राष्ट्रीय शैक्षणिक धोरण हे प्रत्येकाने आपल्या विद्यार्थ्यांपर्यंत पोहोचवण्याकरता मेहनत घ्यावी, जेणेकरून त्याचा जो हेतू आहे, उद्देश आहे, तो नक्कीच साध्य झाल्याशिवाय राहणार नाही. आपल्या सगळ्यांना आता जवळपास 201 लोकांनी रजिस्ट्रेशन केलेलं आहे आणि आता इथे 128 लोक आहेत. सगळ्यांना परत विनंती करेन, आपला जरी वेळ झालेला असला तर जे आपलं 10:30चं सेशन होतं ते 11ला सुरू होईल आणि तसंच आपल्या सिक्वेन्स मध्ये कार्यक्रम चालू राहील. सगळ्यांनी दिलगिरी मी व्यक्त करतो, थोड्या वेळेचं आपल्याला उशिरा जॉईन झाल्यामुळे आपला कार्यक्रम थोडा पुढे सुरू झालाय. पण सगळ्यांना विनंती करतो की आपल्याला जे ज्ञान संपादित करायचं आहे, आपण ऑलरेडी सगळेजण तज्ज्ञ आहात. डिजिटल इलेक्ट्रॉनिक्स अँड लॉजिक डिझाईन हा असा सब्जेक्ट की ज्याला 0-1 ची किंमत नाही कळाली तो कॉम्प्युटरमध्ये पुढे जाऊ शकत नाही. आणि इथे तज्ज्ञ म्हणजे डॉक्टर छाया जाधव मॅडमच्या मार्गदर्शनाखाली आमची सगळी टीम कार्यरत आहे आणि सगळेजण त्यांच्याकडे काही जे प्रश्न असतील निश्चित आपण त्यांना विचारूया, मनातल्या सगळ्या शंकांचे निरसन करू आणि ते योग्य जे काही आहे ते आपल्या विद्यार्थ्यांपर्यंत पोहोचवण्याचा प्रयत्न करू, यात मात्र शंका नाही. मी जास्त वेळ घेणार नाही. फोटो झाला का सर? ग्रुप फोटो. सगळ्यांचे परत एकदा धन्यवाद. आपण ग्रुप फोटोला आपली बहुमूल्य वेळ दिलात. आता हा कार्यक्रम इथेच संपला असं जाहीर करतो आणि आपल्या नवीन सेशनला सुरुवात करतो. ओव्हर टू यू मॅडम. प्रोफेसर तेजल पाटील मॅडम.
Good morning, everyone. Now moving ahead with our FDP schedule, I feel privileged to introduce our esteemed speaker, Dr. Vishnu Suryavanshi, Assistant Professor at Trinity Academy of Engineering, Pune. With over 24 years of teaching experience, he is an expert in VLSI network security, NLP, AI, and has multiple publication and patent to his credit. So, sir, we request you kindly explain your unit. Over to you, sir. Dr. Vishnu, sir.
Okay, thank you, ma'am. I am audible?
Yes, sir.
Okay. So thank you, everyone. First of all, good morning to one and all. I first of all thanks to the Dean Sir, Patil Sir, BOS Chairman Dr. Uke Sir, then Bharati College Principal R.N. Patil Sir, our friend, colleague Dr. Uday Patkar Sir, and our team members, Wani ma'am, Zado ma'am, and all the participants. First of all, I sincerely thanks to all these team members, those who have given a good chance to me for the explanation of that, the first unit of that, the digital electronics and logic design. So as this second year engineering students, for the computer engineering students, we have started the syllabus curriculum for 2024 under the National Education Policy. So here, my screen is visible. Hello, ma'am. The screen is visible.
Yes, sir. Your
Yes, sir.
screen is
Visible. Okay. So for this here, the subject name, as you all of you know, that is the digital electronics and logic design. So in this course, it is a, as per the teaching scheme, all of us know that is it's a 2 hours per week. There are 2 credits. There is a CCE exam for this subject. It is 30 marks, and the end semester examination is for the 70 marks. Now, in this case, what are the course overview of this digital electronics and logic design? The first of all, the prerequisites for this subject is the first year engineering subject, that is the basic electronics engineering. Then the main objective of this subject is that to introduce the digital electronic fundamentals, enhance the problem solving abilities, then to build a strong base for careers in terms of that the computing, automation, and in the embedded system. So the prerequisites for this subject, that is the basic electronics engineering, we want to introduce the digital electronics fundamentals and enhance problem solving abilities. That are our objectives, and the foundation will be this digital electronics subject will be the foundation for the computing, automation, and embedded systems. So the key
sorry to
learning
interrupt.
objective.
Sorry to interrupt,
Yes.
sir. Can you please
Yes.
present your PPT?
Yes, I have presented. Ma'am.
No, just click on the presentation
Just a-
views slideshow.
Now it is visible, ma'am.
Slideshow.
Slideshow.
Sir, yes, sir.
अभी
सर
दिख रहा है?
नहीं एक्चुअली वहां पे देखो न्यू टैब के बाद एक स्लाइड शो करके ऑप्शन है होम के
ये?
साथ. हाँ उसके बाजू में फोर्थ वन सर, फोर्थ वन.
Yes.
यस.
Yes. Okay. So the key
Or
learning
else just-
objectives.
So
It is visible or not, ma'am?
no sir, no sir. Just press F5.
Okay.
Sir.
Okay, it is visible.
No, sir.
Sir, it is visible, but it is not in, full screen mode. So, madam is saying press F5.
F5, sir.
Now it is okay.
No, sir. Still, it's not okay. Sir, just go to slideshow or the view.
Yes, I am in view.
Yes. Slideshow, sir.
Right.
Yes.
Okay.
No, sir. So not visible.
Now here.
Sir, first one from beginning.
Okay. It is visible, ma'am.
Not yet, sir. Sir,
Yes, it
just
is.
click on that from beginning.
Yes, ma'am. I have clicked here.
Yes, sir. Yes, now it's visible. Thank you, sir.
Okay. Thank you. So now here. Okay. So now the key learning objectives for this subject is the first, that is for the Boolean algebra and the simplifications. We need to learn, we need to teach about the Boolean algebra. What are the different laws for this? Then the signed numbers. What are the positive numbers? What are the negative numbers? What about the ones complement, twos complement in the digital systems? We have the combinational circuits where we can teach about the adders, subtractors, code converters, multiplexer, demultiplexers, adder circuitry. Okay. Ma'am, is there any issue?
Sir. Sir, your voice is not visible. Audible. You are not audible.
Yes. Hello. Yes.
Sir, you are not audible.
Yes, sir. Now it's audible.
विष्णू सर तुमचा आवाज थोडा ब्रेक होतोय. ओके.
So now the next advanced learning in this subject is, that is the sequential circuit, where we can teach the flip-flops, registers, counters, and the second advanced learning is, that is the digital system design, where we can teach the students about the algorithmic state machines, logic families, and the programmable logic devices in terms of that the programmable logic array and programmable array logic. So the course outcomes for this subject is that the first CO is that understand and apply key concepts of Boolean algebra, binary number systems, and simplification techniques for the Boolean functions. We need to understand what are the different types of that the Boolean algebra laws, and how we can implement, how we can apply these Boolean algebra laws for any type of that the logical expressions. That is for that the course number outcome 1. The second course outcome for this subject is that study and design and operation of the combinational circuits in the digital system. Basically, in the digital electronics, there are two types of the circuits. One is, that is the combinational circuit, and another one is, that is the sequential circuits. So the second unit for this subject is total study about that the combinational circuits. What are the different combinational circuits? How we can design that combinational circuits? what is the difference between that the combinational circuits and the sequential circuits, what are the important factors, their truth tables, then their reductions for this, that is for the combinational circuits. The third course outcome for us is depends on that the sequential circuits, understand and apply the design and operation of various sequential circuits in digital systems. So this sequential circuits, which is the memory-based circuits like as the flip-flops, counters, we need to understand what are the different what is mean by the flip-flop, what are the different types of that the flip-flops, what are their truth tables, what are their characteristic tables, how we can implement these flip-flops in the digital system. That is for the course outcome third. The fourth is that is the finite state machines and algorithm state machines. That is understand the design implementation of that the finite state machines, ASMs for sequential circuits, and study the logic families. So the last course outcome is for the fifth unit, which is for us, that is the programmable logic devices. Explore the fundamentals and applications of programmable logic devices in the digital circuits. So now, as I'm going to speak on that the unit one, that is for the Boolean algebra simplification techniques. So this unit covers the functional principles of the Boolean algebra and its applications in digital electronics. So Boolean algebra, what are the basic theorems, properties of the Boolean algebra? We need to focus on that the De Morgan's rules. These are the points need to be covered for the students for that the 6 hours as per the curriculum. The third point is what are the simplification techniques? What is mean by the sum of product of some form? How we can minimize the SOP and POS using the K-map, minimization of Boolean function using K-map. It is only for our syllabus. It is up to that the 4 variables. And the case study is given, that is how we can design and optimize of digital temperature control system. So now if we think about that the first point, that is the basic theorems and properties. We must teach our students about that the what is the identity law, that is a plus 0 is equal to a into 1 is equal to a, null a plus 1 is equal to 1, that is component law, involution law, commutative law, associative law, distributive law. So first of all, try to explain the things about that the basic theorems, why we are using the basic theorems about this Boolean algebra. Who has invented these laws? What is the basic necessary behind these basic theorems and properties? So if there are some large logical expressions are there, that large logical expressions like as a number of input variables are to be more, like as f is equal to a b c d bar plus a b c bar d, like these are the some complex logical expressions. And if we go for design of these logical expressions, we require large number of that the logical gates, we require large number of that the AND gates, OR gates, NOT gates. Then if these large logical gates, if we take to design it, then the size of that design becomes very large. So area will increase. Then automatically, if we are using large number of the logical gates or any multiplexer, demultiplexer for our design flip-flops, then automatically the speed of this circuit becomes low, because the input supposed to start from input levels to reach the output levels, it takes maximum time. So speed of the circuit becomes low. Then the power consumption of this logical expression due to the large number of use of that the logical gates will also increase. So as an engineer, we should think about that whenever we are going to design any type of the digital circuits or any analog circuits, we must keep in mind that its area should be small, its speed should be high, and the power consumption, latency, throughput should be small. So by utilizing the Boolean algebra laws, we can reduce the logical expression, which is very large, in terms of that the smaller, and we can get the design as perfect. So that's why we are using the basic theorems and properties of these Boolean algebras for the logical circuits. Now here we can show the De Morgan's law also. That De Morgan's law also can be utilized. We can explain them for reduction of that the logical expression. So you can verify this De Morgan's law by using that the truth tables. It is a two input variable A B, that is 0 0 0 1 1 0 1 1. You can explain the students how the LHS and RHS are matched. Then the second point for this first unit is that is the sign magnitude. That what are the positive numbers, what are the negative numbers, and how the positive number is to be represented binary in terms of that the binary number. Negative numbers, how it is to be represented. That the most significant bit in the sign bit should be 0. If it is a 0, then we can understand it is a positive number. 1, it is a negative number. So you can write some sample, you can explain some simple examples for them. How can make the complement, that is 1's complement, 2's complement. You can teach them that is 1's complement 0 to be 1, 1's to be 0. And in the 2's complements, first make a 1's complement and then add 1. So this is very crucial. This is very important for us to teach the students in the details. We need to take a good practice for the students. Write any logical expression, reduce in terms of that the minimum, so that the design will be very much smaller, give good speed, and the power consumption should be less. So now these are there about that the basic theorems, properties, sign numbers, binary numbers. Now we need to explain the advantages, disadvantages of Boolean expressions. I already told you that in terms we need to explain in terms of area, speed, power consumption. Implement all laws using truth tables. Like you can take an example for the De Morgan's theorem. Take examples on the Boolean logic expression using different laws, and make a good practice in the students that how we can reduce a big or complex logical expression in a smaller one. Now the second point in this unit is that is the sum of product and product of sum. So once we when we go why we are choosing this sum of product of sum, please try to explain these things to the students, as we are in a position to reduce the Boolean expression by using the different Boolean algebra laws. But there are some equations which are some complex equations, and we are not in a position to implement by using that the Boolean algebra laws. Once again, we need to implement the Boolean algebra laws for a proper times. We need to implement. We need to understand how to take a good common factor, so that how we can reduce that. So this must be known to the student. But sometimes as a we are in a position that we can't reduce that logical expression if we know also know the laws also. Some complex circuits will be there. So for that purpose, we can reduce that Boolean expression or logical expression by using the sum of product and product of sum. So why these simplification techniques we are implementing, as Boolean algebra laws implementation is very important. We need to use a correct Boolean algebra laws. We need to take a good common variable, common variable from that equation. Then and then only that equation goes in the reduction process. Otherwise, it will be the time consuming process. We will not be in a position to implement that laws. So these points takes you towards to that the simplification techniques in terms of that the sum of product and product of sum. So what are the disadvantages? You can explain to the students about that the Boolean algebra laws, and you can go further the sum of product and product of sum. So the sum of product is that it is a commonly used method in Boolean algebra and digital logic design for expressing logical functions. So you can give a sum of product. First, the two terms, two variables, three variables, four variables that are in the product. and then the other terms are in addition to that. That's why it is a sum of product. It is the most direct way to implement logic circuits from that the truth table. Easy to simplify and optimize using the K-map, as we know about that the K-maps also. So what are the canonical versus standard SOP form? This also need to be explained to the students. If it is a 3-variable logical expression is there, and the first term contains only 2 variables, but the third term contains that the 3 variables, then it is a sum of product which comes under as a standard SOP form. So how to make this logical expression which is in terms of that the SOP to the canonical. So canonical SOP can be made, can you can teach how to make in terms of that the canonical form, that is a plus a bar, which variable is to be absent, that variable can be taken in terms of that the a plus a bar, b plus b bar, if b is to be absent over there. Then the typical standard SOP form examples are like as a y is equal to ab plus bc plus ac, f is equal to a plus b bar c plus ac. In the first term, the remaining two terms, two variables are absent, but in the second term, first variable is absent, and in the third term, second variable is absent. Then also it is a standard SOP example, because there are some product terms and that product terms are to be added. That's why it is a SOP. So from this we can make in terms of that the canonical SOP. So next we have the product of sum is a standard form in Boolean algebra where a logical function is expressed as a product and of some or terms. So you can give the examples for them like as a f for the 3 variables a plus b plus c bar into like in the terms bracket. So it is most directly way to implement the logic circuits from the truth tables as like as a SOP. You can simplify and optimize using that the K-map. Here also there is a canonical POS form, there is a standard POS form. How to write the standard POS form and how this standard POS form can be converted into that the canonical POS form. If all the variables are present in that logical expression, if it is in terms of that the sum of product or in terms of that the product of sum, then it is called that is the canonical POS or the standard POS or the standard SOP, that it should be in the addition, and into that the another term should be, both variables should be in the addition. So that is for that the standard POS example. F is equal to a plus b, a plus c. So here some variables are absent. Then also we can call it as a standard POS. But we can't say it is a standard. We can't say it is in a canonical form. To make it in terms of that the canonical form, we can add the a plus b plus the which variable is to be absent, that will be the c. So you can make it a c into c bar. So like that way you can convert. Sometimes in the last old syllabus in 2019 in the INSEM, there may be some 2, 3, 4 marks questions. Make this is as a canonical form of the SOP and POS. So we focus on this canonical standard, give the clear difference about the statement, these two terms to the students. Next, there are K-map. There is a 2-variable K-map. Then how we can draw the 2-variable K-map in terms of that the SOP, POS, 3-variable K-map in terms of that the SOP, POS. There are different ways that it sometimes it is given in some books. It is given in a vertical form. Some people are using in a horizontal form. It's whatever it's your choice. Just give to them in either vertical or horizontal. Depends on that the lectures. So this the design, how we can draw the 2-variable, 3-variable K-map, 4-variable K-map, and how these 2-variable, 3-variable, 4-variable K-map are to be mapped in terms of that the SOP and POS. So in this case, I have taken one 3-variable table here where the x, y, z are my three variables. So these three variables maximum possibilities are to 0 to 7. That are the total 8 possibilities will be there. So then the product terms m0 you can take as a min terms m0, and that will be written as a x bar, y bar, z bar. So in terms of that, the POS you can take as a max terms, and which will be the sum terms. So m0 is equal to x plus y plus z. That is max x, y, z. So you can represent for these three variables, two variables, four variables. Have a good practice about up to, as per the curriculum, it is they said up to that the four variables. So try to take ask the students to make a good practice on the two variable, three variable, four variable K map in terms of that the min terms, max terms. So now the steps to solve expressions using the K map. Select the K map according to the number of variables. Identify min terms. Sometimes in the university question papers, we we faculty members only ask that f of is equal to f of a b c is equal to summation of min terms. We will give some 0, 1, 2, 3. But students doesn't understand that which type of K-map I should implement for this logical expression. If there is a logical expression asked in the in-sem examination or in the end-sem examination, f of a, b, c is equal to summation of min terms. We faculty members only gives 2, 3 min terms like as a 0, 1, 4. But he don't know which type of the K-map I should use. I should go for the 2 variable, 3 variable, 4 variable. They are the mixed combination. Students are to be there. Some are talented, some are average, some are medium range. So by occupying all these, by keeping all these things in mind, we need to teach them from the basic levels. That first of all, try to understand f of a, b, c. It means that they have given only three variables. Again, you need to check that what is the range of our min terms. The range of the min terms in terms of that, what is the minimum value in these min terms and what is the maximum value in these min terms. If it is less than 7, so it is a 3 variable. If it is less than 3, it is a 2 variable. If it is less than 15, it is a 4 variable. So ask them to check in terms of that the variables, in terms of that the presence of that the min terms also to the student. And then think about which type of the K-map they need to be used here. As three variables are there, three variable K-map they can take. So identify min terms or max terms as given in the problem. For SOP, if it is a sum of product, as all of you know, we have taught so many times about this digital electronics and logic design. So for this SOP, we can take once whatever the min terms are present in that problem or in that statements, that will be taken in terms of that once, and for POS it is to be taken as a zero. Then make rectangular groups containing total terms in power of 2's, and then 2, 4, 8, and try to cover as many elements as you can in one group. From the groups made in step 5, find the product terms, sum them up for the SOP form, or that is for that the POS form. So no zeros are allowed, no diagonal pair is to be allowed in this K map. Then groups should be as large as possible. Try to make a quad. First of all, try to think about that the quad, then go for that the pair, and then you can make the half pair. Like that you can make the grouping for that K-map. Now the last topic under this is the case study, design and optimization of a digital temperature control system. The system is nothing but that the system, it defines that which is a combination, which is a physical combination of some atoms, and that atoms require some input levels, and depending upon the characteristics of that physical components present in that system and how we are giving that the input, the system works. So it is a control system which will be fully controlled by us. So you can explain how we, first of all, try to explain what is system. System is nothing but that it is a combination of the different physical parameters connected to each other as per the design. It requires input, and depending on the input levels and characteristics of that physical components, the system gives the output to us. What is that control system? That the output is to be controlled by the input levels as well as by changing the parameter levels also present in that system, that you can give the definition for them. So this digital temperature control system case study, how we can teach to the students in terms of that Boolean algebra technique. So here you can take a digital temperature control system, monitor temperature using a sensors like we are using the thermistor digital sensors for them, then compares the measured temperature with a set point. You have as a Boolean algebra, we have only turns on off devices like as a heaters or coolers based on logic decisions. In building for this, we can use the digital components like as a logical gates, flip-flops, microcontrollers, etc. So we can have design the control logic for deciding when we want to make heat or cool. So what is the role of the Boolean algebra in this case? You can explain them. Simplify the logical expressions for them. What are the design steps involved in that? What will be our input variables? The like in terms of that, the T as a current temperature, S will be our set point, C will be our control signals, and the preferred outputs. As system, it must have the output. It should be have the outputs, input variables, and the parameters in that. So you can explain them what are the defined outputs for us are the heater and the on or the fan F on. So here you can make a truth table as for the design like as a, if temperature is greater than the set point, then heater should be 1, then the F fan should be 0. You can make some simple table. Then if temperature is less than set point, you can make a heater 1 and the fan F 0. If temperature T is greater than the set point, what is your requirement, either heater or fan? You can explain. You can write the Boolean expressions for them, and you can explain this case study to the students. So if anything is there, you can ask me. So from my side, I think I have covered all the topics. So if anything is there, so you can ask me. Or any point has been left, or anyone wants to add something, my panel members or any faculty members, which I have not covered, that can be added over here.
Thank you so much, sir. If anyone have any kind of queries, please raise your hands.
So as I request all the faculty members, as this is under the NAP, there is a CCE, continuous comprehensive evaluation method is also there. Again, we panel members, Jadhav ma'am, Vani ma'am, myself. If anything is to be there, we will be always on the WhatsApp group in touch with you. And if you know anything related about this subject also, your suggestions, your ideas are also to be welcome in this digital electronics and logic design panel. So thank you, sir, Uday sir.
Sir, thank you.
Thank you, ma'am. If anything,
छान प्रेझेंटेशन आहे.
okay, ma'am.
फक्त आपण what we can do ना की as we don't have any lab for this particular subject, so we can have sometime in class, sometimes simulations like that na. So we will show to the students so that they will feel the experience of a practical
approach, they can get it.
they can get just some simulation na, that we have already, it is available on IIT Bombay's and त्याच्यावरती पण आहेत, तर ते फ्रीली आहे, आपण एकदम असं दाखवू शकतो मुलांना. अंडरस्टँडिंग एवढं माझं आहे. थँक्यू.
मॅम जरा माझा क्लास आहे, मी परत
हो, हो.
12:30ला जॉईन होतो.
चालेल चालेल. हो हो.
बी कॉम्प्युटर.
हॅलो सर. हॅलो.
हा सर बोला. सर मला वाटतं लेक्चर आहे म्हणून गेले वाटतं.
हॅलो मॅडम.
हॅलो.
आय एम ऑडिबल.
हा सर, यू आर ऑडिबल.
Okay. There will be a question based on the case study. Yes or no?
केस स्टडी?
Case study question राहतील का मॅडम?
नाही नाही नाही, केस स्टडी वरती क्वेश्चन नसणार आहेत.
And what about don't care condition? POS,
हा
SOB.
हा, ते असेल सर.
मेन्शन नाहीये म्हणून म्हणलं.
हा हा हा, ते असेल. हा.
म्हणजे युनिट 1 to 5 there is no question on case study.
नाही नाही, केस स्टडी वरती क्वेश्चन नसणार आहे. हा.
Thank you, ma'am. Now I would like to invite Dr. Lavita Vani. And ma'am, are you there? Yeah. Dr. Lalita Vani, Assistant Professor at Bharati Vidyapeeth College of Engineering, Lavale, Pune. She has over 25 years of experience in electronics and telecommunication engineering, known for her work in VLSI design, signal processing, and AI. Her insights into biometric and neural signal processing are remarkable. Ma'am, please proceed with your topic explanation. Thank you, ma'am. Over to you, ma'am.
Thank you, ma'am. Thank you, ma'am. Will my screen be visible? Hello? Hello?
Yes, ma'am.
Visible,
Yes,
ma'am?
ma'am. Yes. Your PPT is not visible, but you are
Right,
audible
sir.
now. Yes, please, ma'am.
Not visible. I'm screen, ma'am. Once again, I'll try. Stop sharing the picture. Once again, I'll share my screen.
Yes, ma'am.
Now?
No, ma'am.
Hello?
Yes, ma'am.
Hello? Not yet.
Ma'am, your screen is not visible.
Yeah. I'm trying to share it.
मेरा FDP है थोड़ा टाइम के बाद.
Ma'am, now? Whether it is visible, ma'am, because it is showing. Hello? Hello, Tulsi, ma'am. Hello, Tulsi, ma'am, whether my screen is visible?
Ma'am, your screen is not visible yet.
What is happening? I'm sharing.
College का Wi-Fi, thank God.
Madam, just wait for a few minutes.
It's
We
no
will try
password for
to
it.
share from our end.
अभी current.
Okay, no issue.
DYPC है ना? हाँ, उसका पासवर्ड मुझे पता है. I did not bring the mouse.
Visual, ma'am, whether you are sharing
Yes.
from your side?
Give me 2 minutes, ma'am. I'll share your PPT.
Okay. From my side.
Mani madam, you can start presenting.
But able to see the PPT, sir. Hello. Hello.
Yes, ma'am.
Yes, madam.
You are
Hello.
visible now.
Madam, please PPT as visible.
Yes. Now it is visible.
Yes, Kadam sir.
Okay.
Yes,
Good morning, one
visible.
and all. Okay. 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 Good morning, one and all. I am Dr. Lita Vani from Bharati Vidyapeeth College of Engineering, Lavale, Pune. I am thankful to present here for the subject Digital Electronics and Logic Design. I'm thankful to Board of Studies of the Computer Engineering Department, then and our management, our principal sir, Dr. Aryan Patil, and then Dr. Uday Patkar, head of the department of BVCOEL Lavale, and the workshop coordinator committee members for giving me the opportunity to deliver, or I can say share my views from second unit of DELD. Can I go for next slide? Next slide, please. Hello. Why I'm
Yes, ma'am.
okay. Next slide. Okay. Now, yes. As everybody has, Vishnu sir has described about the syllabus and the CC pattern and NSEM exam, and he had already discussed the objectives and outcomes. So I'll not waste my time. And in our new syllabus, only 5 units are there, and each unit is of 6 hours. So we'll discuss now about the combinational logic design, which is second unit. In that, we have to discuss all the combination logic circuits, how they are going to design, what are the applications of combinational logic design in various applications of combinational logic design. So this is the syllabus where we are going to discuss factors in that half adder, full adder, half subtractor, full subtractor. Then we are then binary adder, BCD adder. Then the next part is code converter, and last part is case study of the case study. So this slide shows us that which topic is suitable to conduct the or refer the book for the particular topic. So now we'll start with the what is combinational logic circuits. So it performs actually combinational logic circuits. It performs the specific information processing operation and gives a specific output, and that output to perform that operation, perform a specific operation, we are using the basic logic gates. So in previous unit, we already know how to minimize the Boolean expression and get the Boolean expression, so that from Boolean expression we are able to design the logic circuit. Correct. So these actually combinational logic circuits are, we can classify them in three different categories. That is the circuits which we are using for functioning and arithmetical and logical functions, for doing the data transmission, and for implementing the code converter. So arithmetic and logical function here, we have to study the various types of adders, subtractors, then comparison operations somewhere we need. So comparators and some types of ways. Actually, we have a separate unit on PLD. So in this unit that we will not focus much on the programmable logic device, but we'll focus on adder, subtractor, and comparators. And the second category is data transmission. So for data transmission, various combinational logic circuits are implemented. They are multiplexer, demultiplexer, encoder, and decoder. So we have to discuss with the student about all these data transmission circuits, which are made by using combinational logic. And the third part is code converter, which is very important, that we know as digital circuits or the digital electronics totally works on low and high, that is 0 and 1, and it depends on the binary system. But if our data is in binary form, uh, and it is long, means if it is a having multiple bits, then it may create an error while transmitting the data. So we need to uh, convert into coded form. Okay, so we are going for, we'll start with the code converter. Okay, so uh, what are the code converters? As I told you that what is the necessity of code converter, or that we have to represent the data which is in binary form into another form. And so according to that, depending upon the application, we generate various types of code, which is listed here: weighted code, self-complementary code, unit distance code, and so on. Now, we'll see the examples. We'll explain the example to the students that weighted code means what, and the examples of weighted codes are binary and BCD codes. So weighted means what? Each bit, or in the binary number, each bit has a its fixed position, and accordingly we will assign its value. So it is a binary coded, binary code and BCD code. Then another one is self-complementary code, which the example of XS3. The example of self-complementary code is XS3. So how to derive that XS3 code from binary, that we are going to see now. And next one is unit distance code. That is nothing but, the example of unit distance code is gray code. And what is its basic property? That between two codes, there is a single difference, or there is a unit difference between two code, a single bit difference between two code, that we are going to explain to the students, and how we have to form them, or how we have to convert from one form to another form. So like that, every in our syllabus they have mentioned binary, BCD, XS3 code, and gray code. So we have to explain the students about each code, its property, its application, and the code converter circuitry. Basically, we are going to see here the thing I have explained about the application of each code for gray code and all. And the code conversion method become easy for us, because since the student have learned about the Karnaugh math techniques and application of Boolean algebra to get the simplified Boolean expression. So here, when in code conversion circuitry, first we'll explain how to get the specific code from binary code, because our real-time data always, or the practical, we can say the physical data is always we get in the terms of binary form, and now we have to convert it into binary to gray, binary to XS3, binary to BCD, and vice versa also. So there are certain steps which we want to explain them, that first how to get the how to get the different codes from binary to gray. So there are standard methods or standard rules for getting that code. Here I had explained all the rules, that what is the method to get binary to gray code conversion, and after and gray to binary conversion. Once we know the number, so we'll see this example of binary to gray code conversion for 4-bit number, 4-bit binary number. So from the applying the rules of conversion, binary to gray conversion, we can easily write the truth table for binary code, as well as that gray code, which is our output code. Because we are considering binary as a binary to gray conversion, we are considering binary as a input, and gray as a output code. Okay, so what we'll do now, as our standard method design process, in our combinational circuit design process, we apply the standard steps. And what are that standard steps? We require to determine the number of inputs and outputs from the specification. Then we need to derive the truth table for each of the outputs based on their relationship between the to the input. Then simplify the Boolean expression for each output using K-map technique, and apply some Boolean algebra also if necessary. And then afterward, last step, we'll get a logic diagram with the help from the Boolean algebra, which represents the simplified Boolean expression, and verify the design. And then we'll verify the design by analyzing the circuit. These are standard 4 to 5 steps which we are using to build the combinational logic circuit design. Either it is adder, subtractor, means either it is arithmetic or logic circuit, or code converter circuit, or data transmission circuit. We'll apply this procedure. So we'll explain the student that why we are applying, means how we are applying this process and getting the logic circuit for particular design or according to the statement. So here I have shown you the binary to gray code conversion and how to get the Boolean terms or Boolean expression from K-map. Student already knows, from student already studied from they may study from first unit, and then as I told, from logical expression or Boolean expression, we'll decide that which gates will require, and we design the combination logic circuit. This is a combination logic circuit for binary to gray code. Then binary, then come to the BCD. Now binary to gray, gray to binary. Once we teach them conversion of binary to gray, student will be able to draw or get the combinational circuit for gray to binary. Just we have to explain that the rules for conversion of gray to binary code. After that, they'll make the truth table, and they'll from truth table they can derive the K-map and get the logic gate. Then second code is comes in the to the picture. That is very important code. That is binary coded decimal number, which is very easy to represent because it uses the decimal. It represents each of the decimal digits from 0 to 9 with a 4-bit binary code. So we can explain them how we are representing the 1-digit BCD, 2-digit BCD, and since I told binary code and BCD code are weighted code, so we can explain them how to represent the binary coded decimal number in terms of binary form. Then again we have to apply the same method that write a truth table, then write a truth table, then form the K-map and circuit. Here, and the application of BCD, everybody knows they are using the calculator, digital watch, and all. So we can explain them like this. Then next is our XS3 code, which is included in our syllabus. How to derive that XS3 code? We have to explain them the procedure, and it comes under which category that we have shown in the previous slide, that it comes under self-complementary code, or why we called it as a self-complementary, that we have to explain here, and why we have derived this XS3 code, that we have to explain them various applications which I have mentioned here, that is used in digital devices that handle decimal data, such as printers, card readers, etc. Then we have to explain them the conversion, that is from BCD to XS3 and XS3 to BCD conversion. There are standard steps, and XS3 code is very easy to design. Just it has to what we have to do for getting the XS3 number, converting the 4-bit BCD code to XS3 is very easy. That is explained here. Just add 3 with that and get the XS3 code. So it is explained here, and the vice versa, XS3 to BCD also. The circuit which are drawn for BCD to XS3, the procedure is similar. From BCD code is our input. From that, by using the process of getting XS3 code, which is our output, we add 3 to each each BCD code, get the XS3, use K-map. Everybody knows the K-map, and pairing the grouping of adjacent ones. Then here, don't care condition comes in picture. Why we use don't care condition? We have to get the minimized Boolean expression, so that we require a less number of gates to build the circuit, and that's why we are using here don't care and the meaning of don't care. So I think it is necessary to explain the don't care conditions in K-map. Okay, and from Boolean expression we can get the diagram. Now, so the third category, conditional logic circuit, we are come to finish that conversion of the codes from one form to another, implementation of the logic diagram for each code, and application of each code. Now we see the second category of combinational logic circuit, that is adder, subtractor, and comparator. So the basic circuit, and before that, I think before this adder, what are the addition rules? what are the subtraction rules? That is, we know variable can take only either a 0 value or 1 value. So depending upon the variable, a plus 0 means addition rules you have to explain, and then the basic adder circuitry, which is our half adder, that it adds only the two inputs and gives the output. The half adder is a circuit which adds two single bit binary number a and b, and it gives the two outputs from and carry. So block diagram we have to explain. Then as we know the steps, we have to from block diagram and from the specification that we have two inputs and two outputs. So accordingly, we can draw the truth table, and from truth table, since it is only two variable function or half adder adds only two single bit numbers, so it is very easy. By observing the output, students can easily decide that it is a for to build the sum which type of gate it required, and to build the carry which type of gate is required, or they can use the two variable k map and get the boolean expression and draw the logic diagram. So in this way we can explain half adder. Then why we are going for full adder, we have to explain then the what are the disadvantage of half adder. So why we are going for full adder? So disadvantage in the sense what, it adds only two single bits and it doesn't consider the previous carry. That if the previous carry is generated by the circuit, it is not possible with a half adder to consider the previous carry, and hence we go for full adder. So what is full adder? That it adds two 1-bit numbers again, but it considers the previous carry output which is generated from the previous circuit. And then the same method, once we know the block diagram and the specification that we have, how many inputs and outputs, we can draw the truth table. From truth table, by we can solve the each output by using k map, and that Boolean expression gives us the what you can say, the logic gates, which logic gates we are using. So here you can see that by solving the k map for sum or s, we are getting sum is equal to a XOR b XOR c in, and for carry out the expression is like ab plus ac in plus bc in. So we need three input or gate and three AND gates of two inputs. Now, as we know, we have to explain in the application also that for performing arithmetical operations like adder and subtractor, we need the adder and subtractor circuitry. Okay, basically in calculators, in various digital instruments, in timers, in program counters, and in obviously in digital signal processors where we are using this adders and subtractors. Now we can explain them about the half subtractor if they want to go with the routine way or the method which we are applying for getting the combinational logic circuit. That is, from specification we can decide the input output, then draw the truth table and solve the k map and get the Boolean expression and draw circuit. Or here we can easily told them that uh, just very sorry, just by inverting a input and giving as a inverted output to the AND gate, we are able to build, means we are able to build the half subtractor circuitry. And the subtraction rule also we have to explain them, or already they have studied in the previous unit. So here the Boolean expression half subtractor circuitry, same way. Why we are going for full subtractor? Because here we are not using the previous borrow and the borrow which is generated from previous circuit. So we'll go with the borrow here, and instead of C we can write down here borrow B, XY input, and difference D. Okay, and the borrow generated at the output. And same by using the method we can design the circuitry. Then the one after the simple addition and subtraction circuitry, as we have seen the another number systems also, or the BCD code, and this for adding the maximum bit, multiple bits, and which multiple bits, as well as it become easy for us if we use the BCD adder in this while making a complex addition. So BCD adder is nothing but what? it is a digital circuit designed to add two BCD numbers and producing the BCD sum itself. Now we'll explain them the BCD addition rule. What is important here that we know BCD number is from 0 to 9, and if addition is greater than 0 to 9, because two-digit BCD, the answer may get 9 plus 9 is 18, but 18 how to represent is it is greater than 6, greater than 9. So what we do, there is provision of addition of 6, or it is needed to get the valid BCD number. We have to add the 6 and get the valid BCD number. So we have to explain the students about the valid BCD addition, means the rules of BCD addition and the correction logic and carry handling, why we are using this, and then again we'll follow the same method. Here in this, we are implementing the correction logic. That is, if we are getting the what we can say invalid BCD number, then why we are adding 6 only, that we can explain from this truth table and the circuit which we got. That is, since after 9 means BCD representation of 4-bit representation of BCD is from 0 to 111, and but we are not using after 10. We are not using it as a, or we are called it as a invalid BCD. So we consider it as a, here we use the negative logic. We consider it as a 111 from 10 to 15, and we develop the what we can say the correction logic circuit to get the valid BCD from invalid BCD, or how we are why we are adding 6 in the invalid BCD to get the valid BCD number. And this is the circuit diagram. This is the circuit diagram is for by using IC 7483. IC 7483, actually 7483 is a binary adder, okay, binary adder, and by using this combinational circuit or carry and this combinational circuit or the this by using this correction logic circuit, by using this correction logic circuit we can add, we can get the BCD addition. We can get the BCD addition from the 7483 binary adder. So already, hello, is there any problem? Hello.
No, madam.
So now,
No, ma'am.
okay. So like this BCD addition we have seen, and then we have to go for means different types of adder we are discussing. So now we'll think about that. Up to full adder, we know it adds only 2 single bit number and the previous carry. And if we cascade the number of full adders, we can increase the means input bits. That is, A is of 2 bit, B is to build the 4-bit binary adder. And likewise, we can increase the number of bits that is added and urgent and added. So n-bit parallel adder, or we have to discuss this thing also. That is, if we want to add the n bits, so which type of circuitry and how it can be built. So that is, we have to explain here that we can use the cascading of full adder, and here how we are adding it. Suppose A is of, this is of n bit or 4-bit parallel adder, so we require 4 full adders to build the 4-bit parallel adder, and the carry out of the first full adder is acts as a carry in for the next full adder, and so on, since this is a cascading process. And we get for 4-bit full adder, we get the sum S0, S1, S2, S3 and the carry out. So here A0, B0 represent the LSB of the 4-bit words. Yeah, in digital circuits, when we handle the ICs, or we are working on the ICs which we are using for performing for computer, you don't have a practical, but while explaining how the MSB, when writing the truth table, MSB and LSB, don't get confused in that, and otherwise the results may be get different. So that thing is very important, that to explain the LSB position and MSB position in the binary code or any BCD code representation. Now we explain them that if we want to add n bit, we can use n bit parallel adder. It is also called as ripple carry adder. So that means we have to go for the next. That is what look ahead carry generator. Now, why we go for this? If n bit parallel adder adds the multiple bits and we get the adder circuitry, that we observe here that in the above circuit that until and unless C in is coming, we are getting the summation of and this first LSB circuit creates a carry out and it gets as a carry in for the next full adder. Likewise, that carry it gets what you can say ripple. It acts like a ripple. So in the adder circuit, sum and carry outputs will be delayed due to the propagation delays of the gates involved in the full adder. Yeah, will require will depending upon the number of uh, bits which we have to add. Accordingly, we have to use the full adder, and we have seen how many gates are there, gates required to build sum and carry. And the gate itself had some delay at the time of manufacturing, and when the number of gates increases, the circuit becomes complex. So it gives us the delay, which is means valid in the sense that it creates a problem, or it creates a delay in getting the output. So we have to overcome this problem. We are building the another adder circuitry which is called as look ahead carry adder. And how look ahead carry generator circuits are built, that thing we have to explain them, and why we are going for that. So here the look ahead carry generator I had explained here, that how we are generating the circuitry and what changes we are making, and means making in the sense we are assuming and solving the equation logically and avoiding the propagation delay. So here I have explained all the things that what changes we have considered in the full adder circuitry, and here we introduce the carry generator and carry generate signal and carry propagate signal, and the relation between carry generate and carry propagate with the input variable as well as with the output variable, that is xy, and c is the input of adder, and sum and carry is the output of adder. I had explained here all this thing itself. The slide is explanatory. You can easily understood this. Then the circuitry, how it works, and this gives us depending upon the input. You can say 4 input, 5 input, 6 input. You can generate the carry this propagate and carry propagate carry generator and carry propagate signal we can add and get the sum or minimize our propagation delay in look ahead carry generator circuit. So that I had explained here. And in our syllabus, just they have mentioned the look ahead carry generator IC, that is 74182. So just we have to explain them which by using which logic that that IC is made. And since you don't have practical, as madam told us that we can show them on virtual lab how the look ahead carry adder adds the multiple bits. That for then now we finish the second part of combinational logic circuit of the second category, that is arithmetic and logical operation. Now the third category of combinational logic circuit is what? Data transmission. The combinational logic circuits which we are using for data transmissions are multiplexer, demultiplexer, encoder, and decoder. So we have to explain the meaning of what is multiplexer, how it works, the different multiplexers which are available, and how these multiplexers are useful. Means one application for data transmission we are using, and the adder and subtractor. If we want to build using this multiplexer, demultiplexer, it is also possible, which reduces the complexity in the circuit and gives the and reduces the time also. So that we have to explain about the application of this multiplexer, demultiplexer, the definition, as it's here on the slide. I have shown the basic multiplexer, that is according to its meaning, that is, it is a combinational circuit with multiple data inputs and single output. depending upon the control select, or what is the role of select lines, and how the select lines are I can say related, like select lines are depending upon the inputs which of the multiplexer, the relation between select lines and the input lines of multiplexers, we have to told them. And likewise, how it works, we can explain them easily. This is a truth table which explains the functioning of this multiplexer. Then here the ICs which in previous syllabus they have mentioned about multiplexers IC which we have to use. The so 74153 is dual 4:1 mux, and with this IC, what we are able to do first is the data transmission easily. We can send a big data at a time, and that can get controlled from control line or select lines at the output. And this is the explanation about the IC, that it has same input, means what? The output is not inverted output. Means if we transmit 1, then it will give you the output in 1. 0 means it is 0, not in inverted form, and that is here written here, that is 74151. Both are TTL logic ICs, and just you have to mention them, and if possible show the virtual lab for this experiment. Means now we go for multiplexer tree also. What is the aim of multiplexer tree? That if we want to increase the number of inputs for multiplexer, and we have a less number of multiplexer with the less number of inputs, but we want to increase and send the data, we want to increase the input line, then the multiplexer tree is useful. And likewise, I have shown both the examples with 4:1 mux, using 2:1 mux, and for the large multiplexer tree, that is 16:1, means you can build from 2:1, 4:1, 8:1, 16:1, like this. And why we are using this? This many input, again, it has a relation that n input lines, or we can say that 2:n input lines, n select lines are required, that we know. But with the input is always 2 to the power, means input of the multiplexer is always 2 to the power n, and hence it is 2:0, 2:1, 2:2, like that. We have a input lines for particular multiplexer. So 2:1 means 2. So basic multiplexer 2:1 is 2. So basic multiplexer is 2:1, and then we start from 2:2 is 4, so on, 8:1, 16:1. Likewise, the different multiplexers are available. Then we have to explain them that as we can transmit from number of inputs to a single logic circuit at the output, depending upon the control logic or control lines or select lines. Likewise, from a we have a reverse operation also. It is possible to get the reverse operation, and it is done with a circuit. We called it as a demultiplexer. It receives only single input and distributes over a several outputs. So again, the relation between your input line, output line, and select input line, that is 2:n is equal to m, and at a time only one output line is gets selected, which is decided by the m select input. So there are again various demultiplexers are available, 1:2, 1:4, and so on. The ICs in previous syllabus they have mentioned, or which are the basic IC we have used as a 74138 and 74154. That is a dual. It has a dual functioning, that we can use it as a decoder as well as demultiplexer depending upon the enable input. Yeah, enable for both the cases in demultiplexer and multiplexer. Enable is very important input with the select line, because it activates that particular multiplexer or demultiplexer, and it when it is high, when positive logic is used, then if enable is high, that means your multiplexer or demultiplexer is activated, and if it is low, then it gets it deselected. That means for positive logic, your enable pin should be always high, and for negative logic means what? It is in work in inverted form, like that. So we have to explain them the application, then the demultiplexer. Now here, just the comparison between multiplexer, demultiplexer with respect to input, output, and selection lines I have mentioned here, and the various ICs which we want to explain them, and the various now various applications or the use of multiplexer with the help of multiplexer. So here on this slide, we are going to see that we can implement full adder using multiplexer. Again, we'll use the same that adder. So we have to write the truth table for adder. We know the min term concept from first unit, so we write this. And now we can for this what we can do to build this full adder. To build this full adder using multiplex are not shown here, but we suppose now build the full adder, we need 8:1 mux. By observing the mean terms,
Madam, your voice
we
is
can easily
breaking.
say that now
Ma'am, you're not audible.
we have a full. I'm not audible. One. Is it? Am I audible? Am I audible, ma'am?
Yes, but
Am I audible?
voice is breaking little bit.
Yes, yes.
Okay. Now see, as I told you that we can build the full adder using multiplexer. So by observing the mean terms for sum and carry, we can easily identify that we can need a okay. And then what we do, the input. So from 8 inputs, positive, and 3, 5, 6, 7 to the positive means positive. You can say group it and positive logic connected to VCC, and we can means accordingly we can get the output. But if we don't have the 8:1 mark, then we have to build it using 4:1. If you are to build it using 4:1 mark, then make a multiplexer tree and then implement the full adder. So with the minimum input line multiplexer, we can also then also possible to build a full adder with 4:1 mark. Okay, with 2:1 mark. And there the enable pin comes in picture, and the role of enable pin, and which by implementing the multiplexer tree and connecting the copper inputs which we need, means the logic which we use, that we should get high out for that means then high for minterm to get the output for some, like that we apply that logic. So we have to explain them like with the single example. You implement it using means you can implement half adder, half subtractor, full adder, full subtractor using multiplexer. Just explain the one design. Student will be able to do the remaining circuits. Then the last part from this, you can say the data transmission circuit is comparator. Comparator, as the name indicates, it compares the input bits. So one bit comparator, then maximum we can easily design 2-bit comparator also, but more than 2 bit we need ICs where the input bits go on increasing, and we want to find out the comparison. Obviously, comparison is outputs are 3 outputs greater than, less than, and equal to. So we'll explain the same about the 1-bit comparator functionality, and they can design the circuit. Design means what? From truth table you have to draw the K map, and from K map you have to design the circuitry. That is, get the Boolean expression and design the circuit. Likewise, and the last one, as Sam I'm told us that we have to explain about the case study also. So unit 10, they have mentioned the case study of design of binary calculator for BCD input and post complement operation. So what is my suggestion? We know how to convert the binary and BCD input by from binary to BCD conversion. So they already know the conversion and they get the circuitry for BCD in binary to BCD converter circuit. And we know in calculator which operations we have to do, either addition, multiplication, or subtraction we have to perform. So always it is best when we use the we build the subtractor by using complementary circuits or one's complement, two's complement. They already are doing this in the first unit. So here better way by using any simulation software. If we build this and consider it as a case study, then is it okay, ma'am? What I think that for this case study, use the any simulation software and show them
Yes.
the out this. Huh?
Yes.
But
Yes.
because already all the basics, yeah, already basics they are studying the binary to BCD conversion, and we know in calculator we are getting displaying the decimal numbers. So the equivalent of BCD is nothing but binary coded decimal, and they know the addition rule, subtraction rule. So they can implement any circuit, or for electronics they can build it using microcontrollers also. Because using logic gates already we are implementing it in our syllabus. It is mentioned. But for you people, means for second year computer, if they are okay with the implementing this with the microcontroller, then no problem. But I think we can implement it on a by using VHDL, any simulation language. And thank you all. These are the some reference books which I have, which I can suggest according to our syllabus. The books which are mentioned in the syllabus. Thank you all. Over to Tejal, ma'am.
Thank you so much, Vani ma'am. Now I request to all participants to please drop your questions in the chat box. So we will take it at the time of QA session. And now we will continue with our unit 3. Now I request to Dr. Chaya Jagtap ma'am. She is professor at DIT Pimpri with the more than 25 years of experience. She has contributed significantly to research in medical image processing and machine learning. She is PhD guide in SPPU and has several national and international publications. Ma'am, request you to take over.
Yes. Thank you.
Thank you, ma'am.
Just from my side, should I share?
Yes, ma'am, please.
Dr. Chaya Jadhav, madam. Sorry, your name is Chaya Jadhav, not Jagtap. Sorry for this.
Sir, after marriage, my name is Jadhav. Before it is Jagtap. But actually, my PhD degree was with Jagtap. That's why I'm mentioning both the names.
Okay, no issue. It's good.
Yes.
Sorry, Tejal madam.
Is it visible?
Yes, ma'am.
Yes. So, good afternoon. So, respected Dean Dr. Pramod Patil sir, BOS Dr. Nilesh Uke sir, respected Principal sir of Bharati Vidyapeeth, respected HOD Dr. Uday Patkar sir, and today I'm going to present unit number 3 of Digital Electronics and Logic Design. Myself Dr. Chaya Jadhav, working as a professor in Department of Computer Engineering. So I would like to thanks Bharati Vidyapeeth, Lavale, for taking the initiative and organizing this workshop, and whole coordinator team for this. So this is already Vani madam has explained this thing. So just I will go through that. So the teaching scheme for this subject is 2 hours teaching is there, credits 2 are there, and then we have a comprehensive continuous assessment CCE. This is 30 marks and the 70 marks theory end sem examinations is there. So the prerequisite for this particular subject is already students are studied the basic fundamentals of GATE and already in the first year. So this will be the in the first we will discuss that. So now these are the course objective of this. So I will not go through that, but that course objective is basically related to the each unit. So basic Boolean algebra as unit number 1 is nicely explained by sir. Then understanding of sign numbers, which is under unit number 1 also. Then that objective 3 is a to study adder, subtractor, code converter, that will come under unit number 2. And then 4, it will be related to unit number 3, that is a understanding of sequential circuit, flip-flop, register, counters, memory element, etc. And fifth one is exploring about the ASM chart and PLDs and the logic family. As per the discussions in that syllabus, the logic families, it seems to be very difficult for the students. So some, I think some portions again it will be kept in this particular 2014 syllabus. But they should know about what is the fundamentals of the IC. Now, after the completion of this course, student will understood the basic concept of Boolean algebra, Boolean functions, sign operations, combinational circuit, okay, sequential circuit, and ASM, FSM, and the different applications of the PLD. So basically, the importance of this particular subject is it visible screen or should I do? It is not visible, na?
It's not visible.
Yes,
madam, not visible. No?
एक second.
आधी दिसत होते, आता परत दिसत नाही. Yes.
हाँ. Is it visible, sir?
Yes, ma'am, your screen is visible.
Screen is visible, na? Now the basic importance of this particular subject is that the questions are asked on the different examination. For example, GATE examinations and all this competitive examinations, some questions again it will be asked on the combinational and sequential circuits and all these logic families and all these things. Therefore, this subject again it will be introduced in the computer. So these are the content of the unit number 3. So we are going to discuss about the flip-flops, JK flip-flop, SR flip-flop, JK flip-flop, T, D. So these are the converted flip-flop. Then MSJK, then it's truth table, excitation table, and a conversion of one flip-flop to another flip-flop. This will be discussed in the first part, and in the second part, that will be the register, how the data again it will be shifted serially, parallelly, then shift register, and then we are going to discuss about the ring counter, BCD counter, and the Johnson counter. So the weightage again it will be for the 6 hours again. So these are the different references again it will be there. So if you see that in this particular references, T3, that is a GK Karate book, which is not mentioned in the syllabus, but I will, from my side, I will say that this is a good book and which can be used for all the, not even for the unit number 3, but it can be used for the for whole syllabus. So these are the links. Now first, while starting with this particular unit, so first students should know that what do mean by the sequential circuit. Up till now in unit number 2, they have discussed about the combinational circuit. So students should know what is the sequential circuit. Okay. So basically the combinational circuit whose output depends on the current input values, that is the combinational circuit. And the sequential circuit, the circuit whose output depends on the current as well as the past input values. So these are called as a sequential circuit. And this can be built with the logic gate and some storage element, or in other words we can say that there is a introduction of the memory element, storage element or memory element, or that is nothing but it is the flip-flop. So these are the difference between sequential and the combinational, so broadly. Now in detail when you see that, so you should explain that how the sequential circuit, remember something. Okay, so the output depends not only on its current input but also on the past sequence of the input. So before that, so this will be the block diagram. So this is the block diagram of a combinational circuit, sequential circuit. So the memory element again which is introduced, and there is a feedback from again output again to the input. So what we have a combinational circuit. In addition to that, we have a memory element, so which will store something. Okay, so the previous information again it will be stored, again it will be fed back again to the input. So that's why we are saying output is not depending upon the present input as well as the previous output. So normally questions will be asked, what is the difference between sequential circuit and the combinational circuit. So the questions again it will be answer again it will be, in combinational output depends upon the present input, whereas in sequential output depends on the present as well as the previous input or the past output, as per the block diagram just now I have shown. Also it does not have a memory element. Okay, so combinational circuit, as Vani madam has explained the combinational circuit. For example, multiplexer, demultiplexers, all these are the examples of the adder, subtractor. These are the examples of the combinational circuit. They don't have any memory element, whereas in the sequential there is a memory element. Then the third difference is clock input is not required, because just whatever may be the status of input, output will depend upon the present input. So there should not require any clock input to change the state. So we can say that clock input is not required in combinational, whereas clock input is required in the sequential circuit. And these are the examples: adder, subtractors, code converter, mux. These are the example combinational. Whereas any circuit which consisting or whose basic block is a flip-flop are the sequential circuit. That is a flip-flop, shift register, counter. Okay, so these are the examples of the sequential circuit. Normally these questions will be asked for 2 to 3 marks. So this is the block diagram. Now in the sequential circuit, there are the two categories are there. Just it is not mentioned in the syllabus, but just we will explain them how the sequential circuit again they are classified. So there are two types of sequential circuit. One, it is a synchronous, and another one it is a asynchronous sequential circuit. So first we will see synchronous. So in the synchronous, the circuit behavior is determined by the signal at a discrete intervals of time. Okay, we are checking our behavior, again it will be determined at a discrete or predefined interval of time. Second point, the memory element is affected only at the discrete instant of time. So again, here that means in the synchronous sequential circuit, we are applying the clock. So what is clock is used for the synchronization purpose. So when we apply the clock at that particular interval of time only, the behavior of the circuit again it will be observed. Then the memory element are affected only with the arrival of the clock. Okay, when a clock is applied at that time only the it will be gets affected, whether it will store 1 or again it will be store the 0. If memory element uses a clock in the input, the circuit is called as a clocked sequential circuit. Okay, whenever clock is there, Why clock is required? To change the state. Otherwise, we will call it as a latch. Okay. So this is the sequential synchronous circuit. What is the main thing here? Here, signal, it will be determined at a discrete interval of time. Whereas in asynchronous, the circuit behavior which is determined by the signal at any instant of time, randomly. Okay, randomly at any instant of time, the behavior again it can be determined. So we are not going for the asynchronous sequential circuit. We are going to the synchronous sequential circuit only. Now coming to the flip-flop. So what is a flip-flop? Okay, a flip-flop, which is a circuit. Already in the first year they know about the basic definition of the flip-flop. So flip-flop is a circuit that is having the two stable state that can be used to store the state information. Okay, so either the flip-flop can be made to change the state by application of the signal or any control signal. So basically there are the three inputs we can say to the clock. One is a to the flip-flop. One is a clock, and the two control input which are calling it as a preset as well as the clear. Okay, so two states are there. That is a one set state, one other reset state, or we can say that it will produce output as a 0, that is a reset, output as a 1, that is called as a set state of that particular. Now we are calling it as a memory element. So they store the binary information. Okay, so we can keep the binary state until an input is switched, the state that will be received. So there are the different types of a flip-flop depending upon the number of input and how many inputs again that will be affect the binary circuit. So that will be a combinational circuit and the flip-flop. So that will again that will be there. Now first we will see that how again 1 bit memory cell again it can be done. Okay, normally here in this classroom it is expected that if you do these things on the board with chalk talk, that will be better for understanding of the student. So if we solve this particular equation, how? So now this is a G1 and G2. These are called as a cross-coupled inverter. So these are the NAND gates are there. But if I tie two inputs and it will be single ended input, again it will be used, that NAND gate will be worked as a inverter. Okay, and there is a feedback from output again to the input, and this Q state of this G1. Okay, that is always the outputs Q and the Q bar are complement to the each other. Now here we are going to prove that that it will be working as a memory. It will store something. It will be work as a 1 bit memory cell. Now these are the inputs A1 and A2. These are the inputs to this particular inverter. As you know that as an inverter, and then we will see the different condition. Okay, so the output Q and Q are always it will be a complement. And then we will assume any state. Okay, circuit is having a two stable state. Q is equal to 1. Okay, that is a set. Q is equal to 0, as that is called as a reset condition. And the circuit will continue to remain in the same state, and that is called as a memory. You can take any example. For example, A1 is equal to 0. Okay, then output of that is Q is equal to 1. Okay, now this Q is applied here. That means G2 input is 1, again it will be output, again it will be 0. Okay, so again 0 is applied here, Q again it will be 1. So 1 and 0. So it will be Q, if Q is 1, Q bar again it will be 0. But just again this state again it will be latched or again it will be locked. The information is latched or locked in this circuit, so it is called as a latch. Okay, so students should know that what is the difference between latch and the flip-flop. In the latch, information, whatever may be the state achieved by the circuit, it will remain in the same state. This state will not be changed. Okay, and this is a locked, and therefore it will work as a memory element until we are applied a clock to the circuit. It gets latched. So this cross-coupled inverter will will work as a memory element, where if we assume q is equal to 0 or q is equal to 1, accordingly we will prove that how the outputs again it will be store a 1 bit of information. Just you can solve, that is a1 is equal to 0, then q is equal to 1, this is 1, then again it will be 0, and then again it will be applied here. So with the writing on the board, so that will be easy, and student will understood that. Then next is the latches and the flip-flop. So first difference should know that. Okay, the last two popular varieties of the storage element that are in the sequential are the latches, which are the level sensitive. So first, actually I don't have the to draw that. Level means the output will change at the positive or the negative level of the clock, whereas in the flip-flop at the edges, the output will change at the edges, that is either rising edge of the clock or the falling edge of the clock. So these are called as a flip-flop, and both are again it will be working as a storage element. So we have SR and the D latch, and normally we have D, JK, T, SR. Okay, so these are the flip-flop. Then what is the difference between these two? A difference between latch and the flip-flop is that what is latch? Latch is a level triggered, output can change as soon as input is changing. Okay, whereas the flip-flop is the edge triggered, only changes the state when control signal goes from either low to high or high to low. Okay, so this is the difference. It may be asked for 2 marks. What is the difference between latch and the flip-flop? Now coming to the some modified version of the cross-coupled inverter. Okay, now here we will see that we will discuss about the SR flip-flop. Now what we have did, initially the first figure we have as a cross-coupled inverter, but now we have introduced the next two again, the AND gate. So NAND gate again, which is a single input NAND gate, again which will work as a inverter for this. Okay, so G3, G4 are the inverter, and the input which are applied to this are the S and the R. S stands for set, R stands for the reset.
Jada ma'am, sorry to interrupt you, but can you please share the full screen? Thank you, ma'am.
Okay, is it okay?
Yes, ma'am.
Now, as we have the two input S and R, then we will have the different 4 condition, and we have to prove this. Again, this should be drawn on the board by taking the different condition, and we have to assume any one of the output, that is either consider Q as a 0 or again Q again it will be 1. So here in this first condition, we have considered S and R, set and reset, both are the 0. Okay, so if it is 0, there will not be change. Then we can prove that suppose S is equal to 0, R is equal to 1, and suppose we assume Q is equal to 1. If S is equal to 0, as it is an inverter, output of G3 again it will be 1. Okay, then here R is equal to 0, output of G4 again it will be 1. Then now if I consider Q is equal to 0, okay, initially you assume Q is equal to 0, then input to the G2 again it will be 0. So here 0 and here again it will be 1, and then Q bar again it will be 1. So again it will be applied to this particular state. So whatever initially we are assumed, again it will be same. So there will not be no change in the Q. If I assumed Q is equal to 0, Q is equal to 0 only. So there will not be any change. But now if you consider another combination, S1 R is equal to 0, then Q is equal to, again we have to explain with the same thing by writing the value of S, then value of R, output of G3, output of G4, and consider any status of Q, either Q0 or Q1, and prove that. Okay, what we are getting after solving this, that Q is equal to 1, that output is equal to high, and this state is called as a set condition. Now another combination 0, 1, S0, R1, then Q is equal to 0. So that we are calling it as a reset condition. And if you see both S as well as R are 1, then both Q and Q bar will try to become a 1. So you can take that. If S is 1, then output again it will be 0. Here again it will be 0. And if Q is equal to 0, then again it will be, here again it will be 0. So 0 and 1. Okay, here again 0 and 1. So Q and Q bar will try to become a 1 only. So which is not allowed, because Q and Q bar are always complement to the each other. So therefore this condition is prohibited, and this condition that we are calling it as a race condition of the SR flip-flop. So the limitation of SR flip-flop is that we can't apply the input as a 1-1. And this condition we are denoting as a race condition. And now this race condition is overcome in the next flip-flop. Okay. Now again here, this will be the clocked version of the SR flip-flop. Okay. The same thing again it will be there, but we are applying the clock to change the state. So it S0, R0, previous state. Here notation, students should know the notation. What do you mean by the QN? So again it will be the previous output QN. QN plus 1, again it will be the next state. So 0, 0, previous, whatever may be the state of this. S1, R0, set condition, output is 1. S0, R1, reset condition, output is 0, and 1, 1. That is a prohibited condition for the SR flip-flop. Now to overcome this, we have the JK flip-flop. Okay, we used to avoid the race condition which occur in the SR flip-flop. But what do we have here? JK flip-flop. It is having the two inputs J and K, then the clock. So again we can explain the notations of the clock, bubble and the clock. What is indicates, again it will be a negative edge triggered flip-flop. Again there is a preset input, clock input. Bubble indicates which is an active low input. And then output Q as well as the Q bar. So why we are calling it as this asynchronous input. Reset and the clear called as a asynchronous input of this particular flip-flop. So at any time you can change that. Okay, suppose normally the preset and the clear terminal, basically their clear terminal is used for clearing the flip-flop. Suppose I want to do the use this at the counter, as a counter for counting purpose, and counting again it should start from the 0. So before that I should clear all the flip-flop, so that counting will start from the 0, 0. So then preset. The importance of the preset is that suppose I want to start, I want to design a presetable counter, and I want to start a counting from suppose 3 to 8 only. Okay, so with this applications of the preset, you can start the counting from that any counting for 2 or 3 to anything. So that is the importance. And whenever we are using this, again it should be connected to the ground, and if it is not, it should be connected to the VCC. So this is the symbolic representation for the JK flip-flop. And now again JK flip-flop, again with the constructions with the basic gates, again it will be there. In addition to that, here we can see that there is a feedback from output again to the input to the first 3 input NAND gate. Now this 3 input NAND gate, J input is there, K input is there, and both these are triggers that will be clock is applied. Okay, and again we will verify the condition. Okay, for the 3 input NAND gate. So students should know that what is the what is the truth table for the 3 input NAND gate. Otherwise they will not understood. So first 2 input NAND gate they should understood. They should know the truth table for 2 input NAND gate, and then 3 input NAND gate, so that they will understood the explanations for the JK flip-flop. Again we will consider J and K 0, 0, 0 as 2 inputs are there. Total 4 combinations of the input that will be there. So 0, 0 output again it will be 0. Okay, so that will be the hold condition. If J is 1, K 0, it will be output is 1. This is called as a set condition. J 0, K 1, this is a 0, which is called as a reset condition. And when both are 1, 1, so this will be a toggling. That will be the complement of the, if previous output Q is 0, then again it becomes 1. If previous output is 1, next if for 1 1 it becomes 0. So this state is called as a toggling. And also we can see that 1 1, that will be if both the inputs are 1 1, that was prohibited in SR, and that conditions again it is removed. Limitations again it will be removed into the JK flip-flop. Okay. Now this I have explained, so I already have shared this PPT on the group. So in this way, if we explain to the student by writing on the board, the concepts again it will be gets very clear. Okay, 0 0, and assume whenever you are describing this particular circuit, the flip-flop construction using basic gate, anytime you can assume whatever may be the state of Q, either 0 or 1, and then consider the input and just show the output and verify the truth table. Just I have shown this particular thing for the JK flip-flop. If 0 0, there will not be any change. Suppose I have assumed Q is equal to 0, Q again it will be remaining to the 0 only. Okay, and if Q bar is 1, it remains 1. So these are the different condition. For a reset, Q is equal to 0. For set, Q is equal to 1. Okay, and if both are 1 1, it gets toggle. Okay, if Q is equal to 0, then it Q bar becomes 1. If it is 1, it becomes 0. Okay, just now I have explained the importance of preset as well as the clear. So clear, it will clears the output, and it will low at the preset input set Q is equal to 1. So you can use this for the in the setting the value at any predefined by the user's choice. Okay, so when power is switched on, the state of the circuit is uncertain. Either we can't say that it will be having a 0 or 1, and in many application we need to set or reset the flip-flop to the initial state, and initial state we are calling it is for the 0 0. So to accomplish this, we are using this asynchronous input, which are calling as a preset and the reset. Then this is a very popular questions which is asked for so many times in the examination. What is race around condition and how this race around condition is avoided? So it may be asked for 4 to 6 marks. Now first student should know SR flip-flop, limitation of SR flip-flop, how limitations are overcome in a JK flip-flop, what is the again the limitations of JK flip-flop, and what is the race condition, how we are going to remove that particular limitations here. Okay, when both J and K are 1, race around condition occurs. Okay, so before that just I will show this particular waveforms. Okay, so these waveforms again it should be mandatory to draw if a question is asked on the race around condition. So now here this is a enable or a clock input again which is applied in the first EN. Second input is J input, then next is K inputs again it will be there. Okay, and these are the outputs. Okay, so the here one term again it will be written propagation delay. Okay, so what is a propagation delay? So basically it is a time required for the input to reach at the output. It is in the rough way. That means how much time input takes to reach at the output. That is the propagation delay that we can say. Now here we will see that as we know that if J is equal to 1, K is equal to 1. Okay, or if sorry J is equal to 1, K is equal to 0, set condition. J0, K1, reset condition. And if both J and K are 1 1, what will happen? Now here in this case we are using the level trigger. Okay, level triggering means this on the positive level the output will change. Okay, on this level of this particular clock pulse output will change. Now J is 1. J is 1. Okay, here in this case initially J is equal to 0, K is equal to 1. So what is that? It is a reset. So Q is equal to 0. Now here during this particular portion your J is equal to 1 and K is equal to 1. What is J1, K1? It is a toggle. Okay, So initially it is 0, then it becomes 1. Okay, but till j is again continue, again it will be 1, k is also again it will be 1, and clock is also there. So again it will toggle. Okay, now again during this portion, whatever may be the state, again it will toggle and high to low. Then again in the next clock cycle, j is 1, still k is 1, again it will toggle. Okay, this is first time, again it will toggle. This toggling occurring for the multiple of time. So we will not predict that whether my output is 0 or again it will be 1. So this is called as a race around condition. Why it is happening? We are having a level triggered, okay, and a propagation delay. Now I will come to the previous slide. Okay, so this, it occurs when the time period of the clock pulse, that is a width, is greater than the propagation delay of the flip-flop. Again we can see that your width of the clock pulse is high than the propagation delay of the flip-flop. Okay, so due to this, output changes or toggles in a single clock pulse for multiple of time. Again this will happen that whether it is a even or odd count, this is also depend. Okay, so propagation delay is the speed of operations of the circuit. If it toggles for even number of time, that means if it is toggling for 2 times, 4 times, 6 times, then the output is same. But if it toggles odd number of times, 3 times, 5 times, 7 times, then the output again it will be complemented. Okay, how again we will avoid? Here we can see that. Okay, here it is 2 times it is toggling, here it is 2, here it is 2, here it is 4 times. So like that, depending upon that, your output again it will be normal or again it will be complemented. Now we want to avoid this. How will you avoid? There will be the two solutions for this. Either you can use the master slave JK flip flop, or another again it will be a age triggered flip flop. These are the solution. But another way you can do that, the clock pulse should be smaller than the propagation delay. Okay, now just see that propagation delay is so small. So you can't make a clock smaller than this propagation delay. Okay, to avoid the race condition. So therefore we are having the two choice, that is the master slave JK or the age triggered JK flip flop. Now age triggered means your triggering again it will be done on the edges of this particular clock pulse, not at the width. So that is called as a age triggered flip flop. And next again it will be the first solution is a master slave JK flip flop. What is a master slave JK flip flop? Here. So this is a master slave JK flip flop. What we have? One JK flip flop will work as a master, another JK flip flop will work as a slave, and there will not be any complement. And here we can see that the difference. Okay, here for the master we are applying the clock as it is, but this clock is inverted and then applied to the slave. Okay, we have to draw the two JK flip flop, and clock applied to the slave is inverted through the NOT gate. Okay, and there is a feedback from output to the input. Okay, so again Q bar is applied to the first master, and Q is also applied to the along to the master. Okay, so in this way this master slave diagram. So again write a short note on master slave JK flip flop. So these questions again it may be asked. So this is basically two gated SR flip flop. Again it will be connected together in a series configuration, which is having a slave having a inverted clock pulse. The output Q and Q bar, just now I have said, from the slave flip flops are fed back again to the input to the master, with the output of the master flip flop being connected to the two input of the slave flip flop. Okay, when clock is high, okay, we have to give the explanation. When clock is high, master SR locks the input condition. Whatever may be the conditions, it will be gets locked, and the clock is inverted. As you know that through the NOT gate clock is applied. So when clock is inverted to the slave latch will not toggle. It will not toggle. Okay, because clock is inverted. It will remain in the same state, or you can say that slave always follow the master. So whatever may be the state of master, again it will be followed by the slave. When clock goes low, the output from flip-flops are again latched and any additional changes to the inputs are ignored. Okay, and now the slave flip-flops are now respond. Now on the low to high transition, okay, of the clock pulse of the input, the master flip-flops are fed through the gated input to the slave, and on the high to low transition, the same inputs are reflected on the output of the slave, making this type of a flip-flop, again it will be a edge or the pulse triggered master slave JK flip-flop. Okay. Then the circuit accepts the input data when the clock is high and passes data to the output, that is to the falling edge of the clock. So this MSJK flip-flop is a synchronous device and it is only passes the data with the timing of the clock. All these operations are done in synchronizations with the clock, and always master will follow the data to the slave. Okay. So this will be the input output of a master slave JK flip-flop. Here just this arrow on the clock side, these are the edges. So this is the positive edge, this is the negative edge. Okay. Now if you draw such type of a waveform for explanation to the truth table of a flip-flop, the student will understood the concept very nicely. Okay. Now this is J K conditions they have mentioned, and now just we will see for this. Okay, what will happen. Now here we can see that this arrow, okay, on the first clock, this is negative edge triggered, so output will change on the high to low condition. Okay, it's 1 to 0. Status of J is 1, status of K is 0. J is 1, K is 1. So what is the output? It should be set or it should be high. Now on the next clock pulse, on the next negative edge trigger, J is 0, K is 1. Okay, so what again it will be, what is the condition? So again it will be the reset condition. In this way, set reset of this in associations with the clock pulse, you have to explain how this flip-flop again it will be working. Now these T and D flip-flops are called as a converted flip-flop. Okay, so the D means it is a delay flip-flop. The output Q always takes on the state of the D input. So whatever may be the input of D, again at that particular moment of rising edge of the clock. Okay, so this is very important. Output will change on the rising edge of the clock. These things again it will be important while whenever you are doing for the flip-flop conversion. This again student should know. This is the symbolical representation. Only single input, set, reset or preset clear, we are calling it as a Q bar. Clock is applied and this is the truth table. When D is 0, output is 0. D is 1, output again it will be 1. Okay, this is a delay. So this delay flip-flop they are used as in the constructions of the register as a memory element, because they will store the output, or they will remember the or it will store a 1 bit of information. So these are the delay element. Another is the T-type flip-flop. Okay, so again here in JK flip-flop, if J and K, okay, if J and K are 1, the resulting flip-flop is referred to as a T-type flip-flop. J and K are again in the flip-flop conversion, we will prove that JK to T conversion, if we do, J is equal to 1, K is equal to 1. So this T stands for a toggle flip-flop. If T is 0, Q again it will be whatever may be the state of previous output, again it will be maintained. But when T is equal to 1, output gets toggle. If Q is, then it becomes QR. Okay, if initially Q is 0, it becomes 1. If initially Q is 1, it becomes 0. So that is the toggling of a flip-flop, again it will be done. Then these are the truth table. So again questions. Okay, students should know for the flip-flop conversion, truth table as well as the excitation. But before that, why we require this and what is the importance of the excitation table, that should be given. So what is a truth table? It will shows the operations of the circuit Okay, and it will shows the changes in the output whenever input is changes. So the truth table give the relation between input and the output. There is a mapping between input and output. So that is the truth table. So up till now we have discussed so many truth table for AND gate, OR gate, all the basic gates. Output will depend only on the input. Now this is a new concept to the student, that is excitation table. Okay, sometimes there is a need to find out the input condition from the given output condition, and we need the excitation table. What is this excitation table in basic language? uh, you know the previous output. Okay, and if you need the another output, okay, so to achieve this particular output, what should be my input? Okay, if I want, if I'm in a particular state and I want to go to the next state, so to reaching to that particular state, what should be my input? So these informations again it will be given by the excitation table, and these are required for the flip-flop conversion. Okay, so these are the truth table for the and excitation table for the JK flip-flop. Okay, so these things in a one again this. Okay, so excitation table for the JK flip-flop, present state is 0. I want next output, present output my 0, next output I want as a 0. What should be my J and K? Here it is 0, don't care. Okay, these are the predefined tables are there for excitation table of all the flip-flop. If 0, I want next output should be 1, then what should be my input? That is 1, don't care. If 1, next I want as output 0, what should be the input? That is don't care 1. If 1, 1, then what should be the input for JK? That is a don't care 0. Okay, so in this way the truth table and the excitation table of all the flip-flop again which is available. Okay, so similarly for this SR flip-flop, so it is already there, so I will not take too much of time for this. This will be for the D type flip-flop excitation table. Okay, here normally it is observed students were doing the mistakes while doing the conversion. Excitation table for the D flip-flop, present state is 0, next state is 0, D input should be 0. Present state is 0, next state if you want as a 1, then it should be 1. Okay, 1 want a 0, then again it will be 0. 1, 1, again it should be 1. Okay, and next is T. Okay, so this will be the excitation table for the T, that will be toggle. So before that students should know the truth table, and this will be the excitation table for the T type flip. Okay, then next comes to the flip-flop conversion. Okay, so we can convert easily a flip-flop from one type to the another type using the additional combinational circuit. So for the flip-flop conversion, this diagram again we have to explain. So any combinational circuit, okay, so that will be added. Okay, suppose a given flip-flop again it is there. Okay, and we have to convert this particular, for example, given flip-flop is a JK flip-flop and I want to convert this JK flip-flop into T. Okay, so given flip-flop is JK and the required flip-flop is T. So along with that JK flip-flop, I need some combinational circuit. It may be a gate, okay, AND gate, OR gate, NOT, dot gate, any combinational circuit will be there, and overall all this given flip-flop and this, so that will be the required flip-flop. Okay, so here in this case we need is the truth table of a required flip-flop. This is important, that's why I had done it with the bold. The required truth table of a required flip-flop and excitation table of given flip-flop is required. Okay, if you understood this student this, then they will do the easily conversion from one flip-flop to the another flip-flop. Okay, this is example I have given JK to T. So input. Okay, so again I will read. So in this case truth table of required flip-flop and excitation table of the given flip-flop is there. Okay, JK to T. So required flip-flop is T and given flip-flop is JK. So again this will be the truth table for T. Again it will be written present state, next state. So accordingly we will find out the present input for that particular flip. After the conversion we will get J is equal to T, K is equal to T. So that is equal to 1. Okay. Similarly implementation by to the flip-flop, next conversion D flip-flop. Okay. T. So any flip-flop again it will be converted. So normally the flip-flop conversion will be asked for 6 marks. Two flip-flops conversions it may be asked for 3 marks. Okay. So if you do any mistakes for excitation and this, then marks will not be given. Now this we will come to the next, that is the applications of the flip-flop. So switch debounce, switch bouncer again it will be there. So actually it was there in the if we have a mechanical, previously we had the mechanical switches are there. So the A and B, these are called as a throw pole, and this line is called as a throw. So switch again circuit will open and close between these two, but before reaching to either A or B, the circuit that pole will chatter for so many times and it will create the noise. Okay, to remove that, this circuit again it will be used. It is a bounce elimination switch is there. Is it okay up till now? So that we will see for the registers. Okay, so registers which holds a larger quantity of data than the individual flip-flop. So register are central to the design of the model processors. Again it will be there. So there are many different kinds of registers are there. What is a register? Just it is an extension of flip-flop and which can be used to store the multiple bits. So these are used as a temporary storage in the microprocessor. Microprocessor, when you are saying a 8-bit processor, 16-bit processor, it is having a 16 8-bit register, 8-bit register. 8-bit register means what? There will be series of 8D type of flip-flop and which is used for storing the information. Okay, they are faster, more convenient than the main memory. So for accessing the data from main memory, again it will take more time. Instead of if you are having data accessibility through the register, it will be very easy, or it will require very less time. So we'll prefer the more registers that is to be there. Now the types of registers are there. So how we are entering the data and how we are taking the data, okay, from the series of flip-flop. According to that, they are serial in parallel out, serial in parallel out. Okay, that 4 combination, parallel in parallel out, etc. Bidirectional shift register, universal shift register. Okay, so before that shift register, buffer again it will be there. So just we are feeding the data and at the same time we are taking the output. So this is a type of register, serial in. So bit by bit again data will be inputted and we will get the data bit by bit from the output. Serial input, parallel output. This will be the symbolic representation or all the ways how data again it will be filled. Okay. So this next is shift registers, which are composed of D type flip-flop and that share a common clock. Okay, so all the D flip-flops are connected together and a common clock again it will be applied. So the same serial in parallel out. So you can have the example, take a serial input and how data again it will be shifted as it is a D flip-flop. Okay, so D, whatever, if D is 1, your Q is equal to 1 and that Q is equal to 1 again it will be applied to the next flip-flop. Okay, so this will be the 3-bit representation and how much clock pulse again it will be required to get all the data from the output. Again it can be explained on that. Then serial in parallel out, but parallelly data will be taken through the 1 clock pulse. Then parallel in serial out, okay, parallelly data again it will be applied and serially from the last flip-flop again bits can be taken. Then parallel in parallel out, okay, parallelly all the operations can be done, a feeding of the data and as well as taking output from each flip-flop again it will be there. Okay, it represents a memory device. Okay, so So this is the bidirectional shift registers which is there. So in the directional, again we can say that serial shifting as well as the parallel shifting, again it will be there. Then left shift, right shift, all these operations again it can be done with the bidirectional shift registers, again it will be there. So also we can say that this microprocessor chips 885 for example, okay, it is having 8-bit register. Now this 8-bit registers, again it will be there. Now these registers are available in the series, TTL series are there, 7454 TTL series are there. Then we have 7494, 7495, which is a serial parallel, and shift registers, again it will be there. Now the data which is to be entered or taken out from the serial, okay, these are called as a shift registers. Okay, here the shifting again it can be done here in the diagram. Okay, there is a mode control operations line is there. If m is equal to 0, how data will be there, operations again it will be there, and m is equal to 1, how again it will be there. Okay, shift right operation, if m is equal to 1, shift right operation, m is equal to 0, shift left operation there. So this can be explained by this is a D flip flop, take the input, AND gate, OR gate is there, how data again it will be there, what input you are getting to the input for the respective flip flop 0, 1, 2, 3, and how you are getting the output. Again it can be explained in the operations of this shift register. Okay, so this is about the, it is not there universal shift register. Then these are the shift register applications, again it will be there. Another we can say that these shift registers basically they plays an important role when you perform this shifting to the left hand side, okay, shifting to the right hand side. So it will multiply the content by 2, it will divide the content by 2. Okay, so this can be done. So and this similarly again it will be applicable in the microprocessor. Student will see that suppose I am using in the rotate and shift operations in the different instructions in the microprocessor, how data again it will be divided by 2, and again it will be multiplied by 2. So these are the applications of temporary data storage, bit manipulation. As I said, it will be used for shifting. If we shift a left, again it will be divided by 2. If we shift by right, again it will be multiplied by 2. Serial to parallel conversion, parallel to serial, then computer data communication. Okay, again multiple bit number storage, sequence generator, sequence detector, logical operation. So if we give the real-time applications of the this as a sequence generator, for example, in the olden movies, okay, to open a particular lock, they have to rotate that in a particular sequence only, otherwise that locks again it will not be open. Okay, tijori ती खोलणार नहीं है. So like that, so you can give such type of example to the student, so that student will understood the applications of the shift register as a sequence detector and the generator. Okay, in the detector again, if a particular bit pattern again it will not there, it will not produce the output. Now coming to the next, that will be the ring counters. Okay, after completing that, ring counters. Okay, ring counter again it will take a serial output from the last flip flop of a shift register, and also it will provide a serial input to the first flip flop. Here we can see that, so 4 flip flops again it will be there, and the output of last is fed back again into the D flip flop. Then there is a little difference between the ring counter and the twisted ring counter. Okay, just we will see the diagram. Here we are applying the input or data input, again it will be applied to this particular ring counter. As there is a feedback from output to input, it will form a ring like structure. So therefore it is called as a ring counter. Okay, here we can see the truth table. It is very easy. Initially a clock pulse is 0, and we will see that Q0 again it will be 1. Okay, Q0 again it will be Q0 again it is 1. So on the next clock pulse, this 1 again it will be shifted to the next Okay, then pattern will be 0 1 0 0. When you apply the next clock pulse, this 1 again it will be shifted to Q2. When you apply the third, this Q2 again it will be shifted to Q3. Okay, and when we apply the fourth clock pulse, again there is a feedback from output to input. So what is now your output? Output is 1. Now again it will be fed back to the 1. That means it is to the Q0. Okay, so the sequence afterwards again it will be repeating. Okay, so if you are having the 3 flip-flop, so after the 3 clock pulse, sequence again it will be repeating. If I am using the 4 flip-flop, sequence will repeat after that 4 clock pulses. Okay, now Johnson counter or twisted ring counter. Just a minute. So now on the difference here, the Johnson's counter, it is recirculating the last flip-flop output. Okay, that is the inverted output back again into the input. Only difference is that in the previous ring counter we have a Q connected to the D. Now here it is a Q bar connected to the D. Okay. Now this is a truth table 0 0 0. When you apply the first clock pulse, okay, so what will be output? Your 0 0 0 1, because your output is a complementary output, again it will be there, so that's why again it will be 1. Next again it becomes 0 0 1 1, then 0 1 1, then 1 1 1, and then again it becomes starting to 1 1 0, because again it will be a sorry, it is a complementary output. Okay. Sorry. Just I'm trying to give, it is not in the sequential, but just some case study that I have prepared. So that's why I'm sharing this case study. Digital lock system. Okay. So here, whenever that is a keypad based electronics locking system, again it will be there. So digital lock open when a correct code, it is a 101. If it is there, then only gate will produce an output. There will not be, you are not using any memory elements. This is basically, we can say that applications to the combinational logic circuit, and you can have the input and circuit will produce output whenever a particular this bit patterns, again it will be there. If A, B, C 1 0 1, again it will be there, output again it will be produced as a 1, otherwise output will not be, or otherwise output again it will be 0. Okay, so this is a basic circuit, and here we can use the switches, apply the basic gates, and at the output you can have a LED which will produce the output. Okay. Now another case study, just I have prepared for the as a electronic voting machines, again it will be there. So just this is not perfectly, but to understood the functioning of the EVM machines. Okay, here the concept is to candidate will assign a particular button, voter will press the button and it will cast the vote, and circuit will increment the counter for that particular candidate if he has done the voting. Okay, and display will be result will be displayed. Now how we require this some circuitry or components, again it will be required. Monostable multi-vibrator, again in logic gates, again it will be there. Decade counter, which is there in the syllabus, our syllabus IC 7490. Display driver PC to 7 segment display, again it will be required. Otherwise just you can explain the table also. Okay, button A and button B. Okay, if it is 1, button A is pressed, then count for A will be increased. Okay, plus 1. If button 0, no, so count for B is not there. Okay, now A is not pressed, only B is pressed, so the count of B again it will be there. Otherwise there will not be any change. Okay, if button is pressed, then just counter will be incremented by 1, or it will be considered as a vote is given. Okay, for that particular, just I have shown for simplicity A and B only. Okay, so this will be the actual circuit which is to be there for implementing this particular application. Okay, enhancement can be done by using LCDM, and this is the third one, that will be the stopwatch using the flip-flop register, and which is mentioned in the our syllabus. So basically, the digital stopwatch is a fundamental timekeeping device that will measure the elapsed times in a second and the minute. We are using only the 2 digits, seconds and the minute, and which will designing the system using basic digital components, flip-flop, counter, register, okay, and which will help the student for the sequential circuit. Now, what is our objective? To design a digital stopwatch which is capable of measuring from 00 to 00, means minutes and the second format. In this 2 format that will be there, and here to implement the time counting using the digital components will require this flip-flop, mod counter, mod 10, mod 6 counter. So student will learn this counters, 7 segment display, clock generator, okay, and stop and start and stop reset. Okay, so this will be the block diagram, control logic, model 10 counter, display, minute, and the for minute storing the value, and as well as for the seconds register. Okay, so clock generator will convert this value 1 megahertz to 1 kilohertz. Counter, here we are basically using a BCD counter for units mod 10, so that mod 10 counter will count up to 0 to 9. Okay, so your seconds will be counted from 59 up to 59, 00 to 59, and 59 again it will be up, another pulse is upright, it becomes 0. Similarly for minutes also. Okay, 59. So here for unit second, mod 10 will produce digit 9, mod 6 will produce digit 5. Similarly for the minutes also. This will be working principle. When second will reach to 59, and when we apply the pulse arrive, next pulse, so the second will be resetted and minutes counter will be incremented now, and then it will start minutes. When minute reach to 59, next pulse again it will be there, again stopwatch will roll to the 00. Okay, we are using the module counter and the flip-flop and the 7 segment display. So this will be the diagram for that implementation of module 10 counter for second as well as for the minutes. Application, this will be sports time tracking, cooking timer, lab experiment involving the time measurement. Okay, so just students should think on that, okay, how the flip-flop and how the counters again it can be used, BCD counters again it can be used for counting purposes, and again they will easily implement in the lab or in the simulator also it can be implemented. Okay, further enhancement, so you can use the microcontroller for that, buzzer or some integrate to the buzzer system or to alarm system also again it can be implemented. Okay, so now just I thought some the pedagogy that can be just I will share some. So already all of you are using that, but to create a lecture more interesting, or it should not be monotonous just by having a PPT or only the chalk talk. So there should be a mixed teaching, so that student will create an interest as a being a computer student. So they are having little bit less interest to this hardware related subject. So your sessions can be more interactive if you use some just flip the classrooms again it can be done, PBL, project based learning, again it can be done. So small projects again it can be given to the students as they are using doing some small project in the CEP also. So it can be done. Simulation based learning can be done. Then case based learning, so the student will analyze the real world cases and practical lessons for that. Service learning, design thinking, and some game based learning if we used in the classroom, so that the teaching again it will be more, and again it will be very interactive. Thank you.
Thank you so much, ma'am. Now I will invite Professor Ashish Zawke, sir, Assistant Professor at DY Patil Technical Campus, Talega, with nearly 20 years of combined experience in academic and industry. So please go ahead with your topic explanation. Ashish Zawke, sir.
No, madam, he has requested as add him as a presenter.
Okay, ma'am. Sure, I'll do that. Okay. Ma'am, he's already added as a presenter.
Okay, okay.
Zawke, sir, are you able to hear us?
Yes, ma'am. I will share my PPT. Yeah.
Okay, sir. Thank you, sir.
Hope it is visible, ma'am.
Yes, sir.
Okay. So first of all, thank you, Bharati Vidyapeeth College of Engineering, Lavale, and SPPU for giving me opportunity for digital electronics and logic design unit number 4 orientation. So this unit basically focus on the outcome that understand the design and implementation of FSM and ASM for sequential circuits, and the syllabus given is in continuation with the unit number 3. So our unit number 3 is a sequential circuit, and in continuation with that we go with the algorithmic state machines, in which finite state machine and some ASM charts will be showcased, and thereafter we move towards the logic families. Now in a daily life also we move on a say algorithm. So different algorithm will be there. So right from the traffic controller or your mobile or any devices. So we focused on the algorithm only, and then these devices works on their memories. So we move towards the memory as well. So now the syllabus is covered from 2 books. One is the RP Jain and second one is Maurice Mano. So the first point can be covered from the Maurice Mano, whereas rest of the points can be covered from both the books. So these are the textbooks and references given in the university syllabus as well. So now the first point is algorithmic state machine. So every data, or say every every digital application is split into 2 parts, that is data and control logic. So data is implemented with the help of our mux, then thereafter the counter registers, and with the help of control logic we will get the output data. That algorithm state machine will have the chart, and these are the state box, decision box, and conditional box. So here a state box, we can just here see a diagram for the state box, where the left side is for the binary code and the right side is for the name of the state. So whatever may be the binary code we have to implement, it should be on this side, and thereafter in the option register operation or the output, we will make the control statement, and that control statement is given if I want to just move from the one stage to another stage. So that control stage is given at the register operation or the output side, and then we move towards the decision box. So every situation has the two options, either yes or no. That means either 0 or 1. So both that condition will be given through the decision box, and it is connected to the exit path with the help of say conditional with the help of conditional box. So conditional box will make a decision. So conditional box में आपका final output जो रहेगा, so that will be in the final. Then the second, in continuation with that, we have some example. If we want to just showcase 001 as the sequence, so we will start. So first one will be as per this sequence. First one will be the state box. So in the state box, we will start our sequence 001. E is stating the conditions. Either the statement is going through any stage or it is directly giving the output. So it is 0 or 1. If it is going through any condition, so it will be 1. So that means your R value, register value is stored with the 0 and it is given to the output side. If we do not want to store this value or do not want to apply the control, then it is directly committed towards the T2 side. So that is the one example. Another one is example is T1 and 001 signal, where we are adding 1 in that, and with the help of that we are giving a different say output signals. So we can give these two examples to the student, and later we move towards the finite state machine, where Millet state machine and Murray state machine, both machines are given, which are the output conditions. So in case of Millet state machine, the output depends on the input as well as the present stage. That means whatever may be in the memory element, so it will be affect your output size. And in case of Murray state machine, your output is totally depends on the present state. Means whatever may be the input size, it will not affect your output. It will only affect your present state. And both the diagrams given for the Millet state machine and Murray state machine here means for every stage you will write the output. So input with the input and output are combinedly writing in case of Millet, whereas in case of Murray, the stage will be with the output side and the input will be given as a 0 and 1 only. So to explain this, we have to take one any sequence with the help of Millet state machine and Murray state machine, and that one sequence with the help of both the machines, we can explain the difference to the student, so that the difficulty of that student will be minimized, and we can explain the difference with the help of only one sequence. So the definition, and then thereafter the how input changes, output changing, the number of stages required, all these will be covered in the say differences. After that, finite state machines, we move towards the logic families, where there are the bipolar logic families and unipolar logic families. Bipolar means there will be the transistor NPN or PNP. In that there will be NP junction or PN junction. So there are the two junctions. Whereas in case of unipolar logic family, there will be the only one junction. So that will be drain to substrate or source to substrate, or it will be the channel junction. So that means there will be the only one junction in case of unipolar logic families. Thus we consider the MOSFET devices as a unipolar logic families, whereas bipolar logic families we consider the resistor transistor logic, then direct coupled transistor logic, integrated injection logic, diode transistor logic, HDL, that is high threshold logic, then transistor logic, or in case of non-saturated, it will be the Schottky and emitter coupled logic. But in that case, if we look towards the industry point of view, So RTL, that is register transistor logic, diode transistor logic, and transistor logic is very much important. Whereas from the unipolar side, the CMOS logic design is very much important. So as per industry point of view, we have to focus more on this technology, that is RTL, DTL, TTL, as well as the CMOS. The same diagram we can explain. So in case of register transistor logic, so there will be either 0 or 1, means whatever may be the positive values will be described by 1, and whatever may be the negative or lower the value, it should be a 0. So in that case, if we explain likewise to the student, if we are giving X and Y, two inputs, and both the inputs are 0, that means what will happen in case of NOR gate, this junction for Q1 transistor and Q2 transistor, that will be completely off for 0 input, that is the negative input. That's why this transistor, both the transistor will not work. And at this point, that is Z, at Z, it will directly connected with the VCC. So whatever value with the VCC, that will be the highest value in the circuit. So highest value means that logically 1. So output will be 1. If we go towards the another input, that is 0, 1 and 1, 0, whatever may be the value we will insert here. Now, if we insert Q1 at a 0, so Q1 will be completely off and Q2 will be on if we take 1 as an input to the Q2. Now, this time, the resistance of the Q2 is lower than the R3 value. So R3 having the highest resistor, so your current will flow from Z towards the ground, and ground is nothing but the lowest potential in the circuit. So our value will be goes down, so it will output will gives you a 0 value. Same with the 1, 0, and same case with the 1, 1 also. So in both the cases, here the transistors will have a lower resistance value as compared to the R3. So that's why your signal can be directly moved towards the ground side, and it will be equalized to the ground. So ground means 0. The same with we can move towards the diode transistor logic, where your diode will be combinedly D1 and D2. If you notice here the position of diode D1 and D2, and we are giving 0 or 1. So potentially the point after the D1 diode, it should be a high or a low as compared to the point at side A. According to that, diode will be forward or the reverse bias, and that will be forward or a reverse bias condition will be given to the Q side. So in that way also we can explain the diode transistor logic, and then the transistor logic, where we will having the open collector transistor logic, totem pole transistor logic, both the circuits, and only NAND gate, NOR gate, and the inverter. This should be explained. So if we consider a NOR gate, that NOR gate should be explained with the help of resistor transistor logic, with the help of transistor logic, and the CMOS logic, so that student will implement one circuit at a time with the help of different circuits. And we can give the assignments, or we can take activity of the student to engage that student, and for more understanding, other that is inverter circuit and the NAND gate circuit can be implemented by the student. So in that way, student will involve in the classroom, and their difficulty level will be reduced. And then thereafter, we can move towards the CMOS logic. So here also NAND gate, NOR gate, inverter should be explained very well. So again, A and B, if we consider a NAND gate, so A and B, if both are the 0, 0 values, so in that case, both are the 0, 0. That means your output will be directly connected with the VDD. So here, this transistor will turn on and VDD will be output 1. Again, if we consider 0, 1, A equals to 0 and B equals to 1, means B will activate, but A will not activate. A will not activate means it's an open circuit. So Y will not getting a connection with the ground, whereas A is 0 and B is 1. So 0 means PMOS will get activated. So VDD will go to the Y from the A point. So that means VDD will be at the output side, means your output will be again 1. So if both the condition A and B are 1, means A and B from the PMOS side will be not activating, whereas A and B from the NMOS side will be activated, and Y will be directly connected with the ground side and it will be 0. Similarly, we can go with the NOR gate also. So in that case, NOR gate, NAND gate and inverter, if we go with the every logic families, single example with the every logic families, so student will understand very easily. Then there will be the characteristics of digital ICs. So in the unit, multiple characteristics are given. So speed of operation or the propagation delay, power dissipation, fan in, fan out, noise immunity, all these having some numerical values. So student should understand what are the definition, how this will be calculated, okay? And based on that, we should compare the different logic families. Here, if we consider transistor logic family, that is bipolar logic families, so RTL, DCTL, that is direct coupled transistor logic, TTL, integrated injection logic, all these are compared with the help of different features of your characteristics of the say digital ICs. Now the same parameters we have explained in the table. Now there is a last point where we have explained TTL, differentiate between the TTL and the CMOS logic. So here we have compared TTL CMOS logic with the help of different characteristics, that is fan out, propagation delay, noise margin, power dissipation, circuit complexity, and basic gate we can implement with the help of different logic families. So here, if we focused in such a way for this unit, so it will be very easy for the student, and at the same time, lastly, the application is given. Then the case study of that is given in the our syllabus about the vending machine. So take any one problem. You can get a vending machine or the traffic light controller or any mobile device app. Okay. So we are taking one case study, that is design a vending machine controller that accepts ₹1 and 2 coins, but product will be dispensed only after it will collect 3 rupees. Okay. So according to that, we have maintained here the input side C1 and C2. C1 means ₹1, C2 is ₹2, whereas dispense is the output. Okay. So output will be there only if our value will be ₹3 or more than 3. So there are different stages. So S1 is nothing but 0, means nothing is inserted in the machine. S1 is ₹1 inserted, S2 is ₹2 inserted, and S3 is product is dispensed. Okay. So according to that, we have maintained the state transition table. So here for S0, again, it will be ₹1 or ₹2 we are giving. Then for S1, ₹1 and ₹2 we are giving. For S2, we are giving ₹1 and ₹2. Again, S3 is directly ₹3. So you can give any input, you will get the output. So according to that, we have used a state box, decision box, and conditional output box to trigger the dispense with the help of ASM chart. The chart is like that from S0. So for the S0, dispense will be 0 because nothing is inserted. Then thereafter, we have inserted a ₹1 coin. ₹1 coin means it is moved towards the S1. But again, only ₹1, that's why nothing to be dispensed. If we insert ₹2, that is through the C2, then S2 stage we will get, but again, nothing to be dispensed. From stage S1, anyone can insert again ₹1 or it will be a ₹2. Okay. If in S1 we will add a ₹2, so it will be 1 plus 2 will be ₹3. then our condition is satisfied. So it will go to the S3 condition. If anyone adds rupees 1 again, so S1 means 1 plus 1, 2. So that will goes to the S2. So from that S2 again, we have two stages. Either we will add rupees 1 or again rupees 2. In both the cases, if we add rupees 1 or 2, so it will be 2 plus 1 or 2 plus 2. So all that cases, it will be a 3 or more than 3. So it is directly dispensed to the our output. So whatever from the machine we can easily get. With the help of that, we can take any example. For the traffic light controller again, for red it will be the stop. For yellow it will be a wait statement. Then for the green it will be go ahead. So according to that, we can implement traffic light controller as a case study. We can implement coffee vending machine, tea vending machine as a case study. We can implement any app, means whatever say in the Amazon also. If you open the Amazon app, there will be the search bar. If you put first letter A alphabet, then there will be the different stages. So from that you will get the itinerary. So we are taking one by one in itinerary. So there will be the multiple values, but for any one or two product, we can implement like that. So we can explain this unit likewise to the student, and student will understand very easily. So expected questions from this unit will be about the finite state machines and its types, that will be Mealy or Murray machines, or the differentiation between Mealy and Murray machines, or any one sequence is given, that will be 100, 1011, or anything, and that sequence will be implemented either with the help of Mealy or with the help of Murray machines. Or we can take algorithmic state machine that will explain the different say states or different parts or charts of the ASM machine, and then thereafter sequential circuit using the ASM chart we can implement. Then move towards the logic families. So there will be the differentiation between the logic families, characteristics of the logic families, then explaining the working of NAND gate, NOR gate, or inverter using TTL, CMOS, or the RTL logic families. Or we can distinguish between the TTL. In TTL also there will be the totem pole and open collector operation using the TTL. So we can take this also as a question. So in that way we can take this unit. So thank you all. Any questions?
Sir, very nicely explained, sir. Thank you so much.
Thank you, ma'am. Thank you, ma'am.
It's a really nice session.
Thank you, ma'am.
Thank you, sir. Finally, we welcome Dr. Shranti Guru ma'am, Assistant Professor at D.Y. Patil College of Engineering, Agodi, with 23 years of teaching experience. Ma'am, we request you to begin your unit explanation. Shanti Guru ma'am.
Good afternoon, one and all. Hope I am audible.
Yes, ma'am.
Yes, thank you. Let me go to the presentation. Let me me switch off my video. Hope my PPT is visible.
Yes, ma'am.
Yes, ma'am.
Uh, Yes. So I'm with programmable logic devices. Here, it actually we have in syllabus from PAL and PLA. Basically, it is fusing of and or arrays. Okay, means instead of going for the design, particular application specific design, which will lead to, if it is of no use, then we have to, just the design or the device will be of waste. So there is PLD available where there is and or array of and or gates are available with the buffers which are with including actual input and inverters. So using which we can develop any circuit we can go for SOP and also POS. We also can implement any combinational circuits and the sequential circuits. And as such as the definition, we could say it is we could change it for any program. So that is why it is called programmable logic devices. Here the devices examples I have mentioned. PROM is actually a programmable logic device, and PLA is programmable logic array, and PAL is programmable array logic. What is the difference between PLA and PAL is, in PLA, we could fuse any AND gate with any OR gates. In PAL, the OR gates are fixed and we have to choose that particular OR gate for the chosen AND gates. And the next advancement in that is complex programmable logic devices and then FPGA. So PLD is the function which is not fixed and can be programmed to perform different functions. So here are the types of PLD where and array is fixed in PROM. PROM is hope you you can make out, which is a ROM memory which is programmed for your read and write cycle. So which is programmable, and FPLA is programmable AND array and OR array. PAL is AND is programmable, OR is fixed. So it is so on. In PLA, both are fixed. So here the building blocks are and OR arrays, and the method used is fusing it, and the examples for your any memory. So advantages of your PLDs are we can it's cost effective, and we can reduce the board space. Actually, my PPT is I mean, kind of to say, I mean, there is some problem with my connecting with my actual PPT. So this is what I have here currently. So I can share the complete PPT later on, once I fix it. Thank you, one and all.
Thank you so much, ma'am. Now we will begin with our QA session. If anyone has question, just feel free to raise your hands or drop it in chat box. We will take them one by one. Now I request to the speakers kindly address the queries from our participants. Jadhav ma'am.
Dr. Chaya Jadhav, madam. Can you hear me? Yes. Okay. Dr. Lalita Vani, madam, can you hear me?
Sir, yes, sir.
Yes. Dr. Ashish Jauke, sir. Sir, Ayat
Yes, sir. Yes, sir. Yes.
Dr. Vishnu, sir. Okay. Please continue, madam. Professor Tejal, madam, please continue.
Okay, thank you, sir.
Shanti Guru, madam, you are available? Yeah, please. Okay. Please continue.
So our first question is, for case study, what are the students expected to submit? So our first question is, what we expected from the student when they are submitting the case study?
Actually, students should understood that, and simulation again it will be from my side. It is not mentioned as it is here what is to be submitted, but just a small project like that you can ask student to prepare that particular document, and if it is you can implement that. So that is from my side. It is not mentioned anything like that, but students should know the concept and implement. They should implement in a practical way. So that will be the motto behind assigning this task. Like a report along with that practical model, if it is, that can be done.
Okay.
Thank you. Ashish, sir.
So this is
You
from
want to speak some?
my side, views from my side.
Ashish, sir.
Sir, as per case study, it is just to explain the concept, sir. So students should get acquainted with the concept, whatever may be the explained through the case studies.
Okay. Okay. Next question, madam.
Okay. So second question, ma'am. So, what will be the question paper format for NSEM exam? Please give some information about that from Professor Sumit Lohote.
I think the clearly it is mentioned in NEP syllabus that we have to apply Bloom's technology. So the question paper pattern will be there strictly by forming the question forming should be according to the Bloom's technology.
Sir.
And
मॅडमच्या नंतर तुम्ही पण सांगा.
Yes, sir. Actually, question paper pattern should be as per the Bloom's taxonomy and based on the outcome also. And again, the CC and all that stuffs are mentioned in the syllabus initially.
माझं एक वैयक्तिक मत आहे, दिस इज माय पर्सनल ओपिनियन अगेन.
Yes.
Question paper is if the student is weak, still he must complete this what we can say, he must be passed in that particular examination. And if the student is brilliant or extraordinary, we can say, जर का उत्तुंग हुशार मुलगा असेल तर त्या मुलाला आपण अशा प्रश्न विचारले पाहिजे की त्याला ते कॉम्प्लिकेटेड वाटले पाहिजे. सर्व गुण संपन्न मुलांना पास व्हायला पाहिजे अशा प्रकारचा फॉर्मॅट तो परीक्षेचा असावा. असा एक कुठलाही फॉर्मॅट नाहीये, पण तो फॉर्मॅट लवकरच क्रिएट होईल and that format will be shared to each and every faculty members.
Yes, sir. Level, all the levels should be covered in that question. So all questions should not be at the level 7, level 4 like that. So all the levels, again, it should be done. And there is not mention up till now okay, what is the weightage for unit number 1, unit number 2 like that. So 70 marks, I don't know how again they are classified. But it is, I think 70 is covered in for all the unit. 30 is also 12, 12 and 6. So 30 marks will be divided in that and 70 marks will be for whole portion. Yes, yes. If I'm correct.
All 5 units, yeah.
All 4 unit.
हे सगळं सिलेबसच्या कॉपीमध्ये दिलेलं आहे. सगळ्या शिक्षकांना विनंती वाचा, त्याच्यामध्ये सगळ्या गोष्टी दिलेल्या आहेत. आपण जर का डिटेल वाचलं तर आपल्या सर्व लक्षात येईल. ठीक आहे. Next.
Okay, thank you everyone. Now our next question from Dr. Mahendra Sarungi. He wants to ask, from syllabus, mux tree and demux tree topics are not mentioned. So question is that in final theory exam will there be a questions on this particular topic?
According to me, it is I'm giving that. According to me, it is necessary because it is one of the application or use of multiplexer, demultiplexer. So students should understood it. What is the use of multiplexer? But we'll decide and we'll see whether if it is, and it is easy. So we can ask the question on mux tree also. But we'll discuss and if the pattern means all of them, all of you are agree, means our panel is agree, then no issue, I think. We'll convey this message.
Okay, thank you, ma'am. So our last question from Professor Mansi Basutkar. She wants to know how to prepare assignment questions.
What is the question, madam?
She wants to know how to make an assignment.
Assignment means I'm not getting.
In
questions, theory questions.
Yes, unit wise, how to create it. Is there any criteria for to create a particular for the assignments?
Actually, again assignments, again it should be prepared unit wise, and again they should have the Bloom's taxonomy in that assignments. Unit wise question. Normally we used to give student unit wise question bank, so that can be done. And just you can refer the previous question paper, what type of questions again it will be asked on that particular unit.
माझं एक वैयक्तिक ओपिनियन आहे सगळ्या शिक्षकांना. यू आर लॉट ऑफ एक्सपिरियन्स. यू ऑलरेडी taught this subject from last consecutive so many years. सिलेबस बदलला, नाव बदलला, याचा अर्थ असा नाही की त्यातले सगळेच कंटेंट बदललेले. त्याच्यात 01 आपलं तेच आहे, फ्लिपफ्लॉप तेच आहे, GT, JK सगळं तेच आहे, मॅपिंग तेच आहे, सगळंच आहे. गेट्स, युनिव्हर्सल गेट तेच आहेत, काही बदललेलं नाही. तुम्हाला जर वाटतंय की हे आपल्याला तिथे शिकवणं गरजेचं आहे तर तुम्ही तो टॉपिक आपल्याला थोडा वेळ का होईना ऍटलीस्ट ओरिओ ऑफ दॅट पर्टिक्युलर टॉपिक यू हॅव टू एक्सप्लेन टू द स्टुडंट. असं होता कामा नये की सिलेबस मध्ये नाहीये मग आपण शिकवायचं नाही. काही गोष्टी या मोगम मध्ये असतात, आहे की नाही. आहे की नाही. तर त्या पद्धतीने आपण ते काम करायचं आहे.
Yes, sir.
कोणत्याही शिक्षकाला माझ्यासारख्या पामर जीवाने किंवा हे 5चे एक्सपर्ट ते सांगणं गरजेचं नाही असं मला वाटतं. जरी नॅशनल एज्युकेशन पॉलिसी आलेली असली तरी दिस इज माय पर्सनल ओपिनियन की यू आर लॉट ऑफ एक्सपिरियन्स. आम्ही तर हे सगळे लोक शोधत होतो की कोण येतंय आणि कोण शिकवतंय. ओके, तर तुम्ही पुढच्या वेळेला आपण लागलं तर अजून आपल्याकडे 8 ब्रँचेस आहेत. त्यातले आत्ताशे DLD चे 2 वर्कशॉप झाले. उरलेले 6 वर्कशॉप करता तुम्ही पण एक गेस्ट लेक्चर म्हणून या. दिस इज माय हंबल रिक्वेस्ट टू एव्हरी फॅकल्टी मेंबर दोज आर रिमेन प्रेझेंट हिअर. ओके, तर मी तुम्हाला विनंती करेन की असं काही विचार करू नका काय विचारायचं आहे, कुठला प्रश्न येईल. सिलेबसच्या बाहेरचं येणार नाही एवढं मात्र नक्की. आणि सिलेबसच्या आजूबाजूचा काही टॉपिक जर का सिलेबसमध्ये मिस झाला असेल तो आपल्याला शिकवणं गरजेचं आहे. असा क्रमप्राप्त धरून शिक्षकाने तो विषय शिकवला पाहिजे हे माझं एक शिक्षक म्हणून वैयक्तिक मत आहे. विथ ड्यू रिस्पेक्ट ऑफ छाया जाधव मॅडम, वाडी मॅडम अँड ऑल. ओके, बरोबर ना मॅडम, काही चुकत नाही ना?
नाही सर, बरोबर.
म्हणजे आशिष जावके सरांना माहिती आहे की प्रश्नपत्रिका काढताना आम्हाला किती त्रास